Hello, my ninja warriors. So please let me know in the chat box if I'm perfectly audible and visible. Today, we are going to start the most awaited chapter, that is indefinite integration. A little longer chapter, I would say, but longer also, lengthy chapter also. And towards the end, by the end, to an extent, indefinite integration is heavy and intense chapter as well. But you know what? If you focus on the 3/4 of the chapter, the 3/4 of this particular chapter is absolutely lovable and adorable. Okay, so and you know what? I know that you will be asking me that, ma'am, tell me honestly that how important this chapter is for JEE Main. So let me be very clear. If I talk about indefinite integration individually, so hardly one question you will expect from this chapter. But do you have a privilege of skipping this chapter because of that one question? And this, since this is a very big chapter, I would say absolutely not. Why? Because you know what? This chapter is prerequisite to upcoming high-weighted chapters like definite integration, differential equation 2, high-weighted chapter, and area under curve also. It is one of the low input chapter, very small chapter. Okay, so 3 chapters you will be sacrificing. And you know what? If you talk about 3 chapters, so 2 plus 2 plus 1, that means 5 questions. 5 questions meaning 5 for the 20 marks you are going to eliminate from your JEE Main. Okay, so I think you all should do indefinite integration. At least the basic concepts should be clear, the basic formulas should be clear, and substitution method should be clear to you, so that definite integration, differential equation, and area under curve will be sorted. Now, how I can help you with this thing? Okay, so so I'll be telling you that what things are important, what things are not so important throughout the session. Okay, let me just check. Okay, Harsh Dubey, welcome to the session. Make sure that you're liking the session. And you know what? Just stay with this whole chapter and you will realize that indefinite integration is very much like enjoyable chapter. You will be enjoying this chapter. Okay. Thank you so much, Harsh. And rest everyone, the moment you join, I can't see any likes on this session. See, I have started taking regular sessions on this channel because JEE Main is round the corner and I'll be bringing more such session as well. मैं बहुत सारे ऐसे sessions लेके आने वाली हूँ, है ना? तो पहले one shot में आपको पूरा एक session complete करके फिर important previous year question, important things we are going to discuss in that. Okay. So make sure that you hit the like button. Okay, let me be the first person to like this session. Okay, all right. Yes, everybody, shall we start? Okay, so I know that some of you might not be aware about me, that who is this ma'am. So this is my brief introduction. My name is Namrata and I have over decade of teaching experience in both online and offline. These are my credentials, as you can see, and soon, super soon, I'll be sharing some amazing ninja techniques so that you can do the questions in less time as much as possible, because in mathematics, you know, time is the very big constraint. Time management is the thing that you have to learn, and you can't learn time management in the last day of mathematics. You have to be very active about time management thing since a very long time. So now only 3 months are left. Okay, so we are going to start with indefinite integration. Just give me a big thumbs up and we are going to start it. Okay, non-stop 5-hour session will be there. So yes. Okay, all right, let's start. Yes, I am also excited for today's session. Chalo, let's start. Okay, so integration. See, we have already studied differentiation, and I told you also, some people say, ma'am, start integration before differentiation only. But you know what? Indefinite integration, I cannot start before differentiation. So first and foremost thing, or the prerequisite is prerequisite is nothing but differentiation. So at least the basic formula of differentiation and basic techniques of differentiation should be absolutely clear. Okay, all right, chalo. So as the definition says, as the definition says, f and g are continuous function of x such that g dash x is f. That means derivative of g of x is nothing but f of x. That is what is given. Now integration is the reverse process of differentiation, which is also called as antiderivative. Anti means opposite or reverse. Okay, and also known as primitive of. Please understand, in some, oops, what is happening in G bond? All right, I am back. There was some glitch with the internet. Internet is back now. So yes, what I was telling you is, in short, that the derivative of g of x is fx. The derivative of g of x is fx. So the integration of fx will be g of x. That's it. Okay, because see, integration is the reverse process of differentiation that you have to keep in mind. So if I say that derivative of sine x, can you tell me what is the derivative of sine x, ma'am? Cos x. So simply integration of cos x will be what? Ma'am, sine x. Okay, plus c. Now let's understand everything. Everything is normal now. Like, am I visible now? Just give me a big thumbs up. Okay. So over here, understand, fx, integration of fx over here is nothing but gx. Okay. And in indefinite integration, we have to apply integration constant as well. Okay. Understand. Derivative means breaking. Integration means summing up. Here C constant is just a little bit adjustment. Suppose you are adding. Suppose I tell you that add 1000 plus 2 lakh something. 2 lakh. 2 lakh plus 5 lakh plus 1 CR. Okay, 2 lakh plus and 5 lakh plus. You'll be like, okay, 1 CR. These will be 7 lakhs and 1000 rupees. So 1 CR, 7 lakhs and something. 1 CR, 7 lakhs plus. This is how you're going to answer me, approximately. So plus. So plus C means there is some adjustment, okay, over here. So understand, whenever we are adding, why there is a lag? Huh? Oops, what is happening? Why is this happening? Okay. So here, understand. First of all, let's understand the terminologies as well. Why? Because in JEE Main, sometimes they will directly ask, 99% so they will ask find the integration of. But you know what? Sometimes in like 3 to 4 years, once in 3 years, they can ask that find the antiderivative of some function. Find the primitive of some function. Okay, so you should be aware. Now whatever you are integrating is known as integrand with respect to which variable you are integrating right now with respect to x. It is variable of integration and c is constant of integration. Okay. Now some basic formulas we are going to study. Basic formulas of integration. Integration of x power n will be what? X power n plus 1 upon n plus 1. So suppose somebody will ask you what is the integration of x cube. Formula apply. Okay, it is going to give you x power 4 upon 4 plus c. Okay, just increase one power and divide by the same value. So x cube, it will be x power 4 plus upon 4. Okay, I told you already e power x. E power x is what? Sigma bro. Okay, sigma batch, sigma bro. Okay, so e power x over here is something, if you differentiate, you're going to get the same value. If you integrate also, you're going to get the same value. Now, one more thing, I don't know how many of you have noticed that x power n integration, this formula is valid only if n is not equals to minus 1. What happens when n is minus 1? Tell me. When n becomes minus 1, it is going to become 1 by x. So, integration of 1 by x, this formula is not valid. Integration of 1 by x is nothing but log of mod x. Okay, this is how it is. Now, one more thing. Tell me, what is the derivative of a power x? So, ma'am, derivative of a power x is equals to a power x log of a. Okay, now what is the integration of? So, integration of a power x log a will be what? Ma'am, a power x plus c. Okay, plus c will adjust. Now, if somebody asks you, no, but what is the integration of a power x? So, this log a you have to shift towards the right hand side, and this is how you are going to be answering. Yes? Similarly, I told you that derivative of sin x is cos x. So, integration of cos x will be sin x. Now, derivative of cos x is minus sin x. Derivative of cos x is minus sin x. So, integration of sin x would be minus cos x. Minus sign got adjusted. Clear hai kya? All these formulas are clear. All these formulas are nothing but if you remember the derivative, the reverse you will be able to understand. Now tell me, what is the derivative of tan x? Ma'am, derivative of tan x is sec square x. Integration of sec square x will be tan x. Now tell me, derivative of cot x is, I told you while teaching differentiation, cot x, co. So ma'am, derivative of cot x is minus cos x square x. So now integration of cos x square will be minus cot x. Okay. Derivative of sec x is sec x tan x. So integration of sec x tan x is sec x. Okay. And again, derivative of cosec x, co is there, co. So derivative of cosec x is what? Minus cosec x cot x. So integration will be minus cosec x. Okay. Now, what we are going to do is, we are going to do a couple of problems back to back. Okay, back to back problems we are going to do. Okay, let's do it. Yes. So mini problems, concept building, confidence boosting problems. So you have to solve it with me. The very first problem you are seeing is 2 power x multiply e power x dx. And I know that a power x, formula you know, integration of a power x dx is a power x upon log of a plus c. Here a could be any constant. Okay. So can I just write 2e power x dx? So this 2e is what? A only, constant. Integration direct formula, if you apply, it is going to be 2e power x upon log of 2e plus c. Easy peasy till now. But you need to solve it with me. Otherwise, what will happen? 2-3 questions you'll be able to understand. Gradually, you'll be like, what is happening? Only if you're going to solve it with your pen in your notebook, then only you'll be able to catch up. Chalo, next question. 1 minus tan square whole upon 1 plus tan square. Okay. Now, don't you think that this is nothing but, understand, this is nothing but the formula of cos 2x. Cos 2x. Think about antiderivative. Think about antiderivative. So, ma'am, first of all, okay. Ma'am, derivative of sine 2x. Let's differentiate times sine 2x. So, ma'am, derivative of sine 2x is what? Cos 2x. And ma'am, chain rule, 2 will also get multiplied. Yes or no? Do not think about substitution. I have not told you anything. I have just told you antiderivative. So we are thinking that what will I differentiate so that I get cos 2x. So understand, now this 2 over here, you can see the 2. This 2 I am going to delete from here and divide. So understand, sine 2x by 2, if you are going to differentiate this, you are going to get cos 2x. So that means, what does that mean? That integration of cos 2x dx, reverse process na, is 1 by 2 sine 2x plus c, do not forget. Final answer is what? Half sine 2x plus c. Okay? Yes? Chalo, next question ready? Next question. In the next question, I think we should simplify the expression first. What do you think? Let's simplify the expression. So. Okay. So I think that from the new denominator, let's take something common. I think root x I can take common from here. And inside the bracket, it will be x. Now, if x is there, you have taken root x common. Root x will be remaining plus 1. Root x plus 1, let's keep it as it is. And this over here, oops, x square minus root x. Again, if I take root x common, so what will happen? It is going to be x root x minus 1. Root x is getting cancelled out. Okay. All right. Now, what is this? Integration dx. Root x plus was 1. I am going to keep it as it is. See, before integration, now you have to simplify it. Simplify this. Can you see this is x power, see x power 1 and x power half. Correct or not? Which is x power 3 by 2. Also can be written down as root x cube. So this right here is root x cube minus 1 cube. Whole upon x plus root x plus 1. A cube minus b cube, anybody? A cube minus b cube. So root x plus 1 keeping as it is. A cube minus b cube. Question not visible? Question not visible? Shall I increase brightness a bit? Is it visible now? Okay. A cube minus B cube, ma'am. A minus B and A square plus AB plus B square. A square, so root x square plus AB product and plus B square. Can you see that x plus root x plus 1? Integration is there, dx is there. This over here is getting cancelled out with this. Root x plus 1, root x minus 1 is only thing which is left out, which is nothing. A plus b, a minus b is a square minus b square. It's x minus 1 dx. Okay. Now x minus 1. You know what? While integration, see, the way we used to differentiate x plus 1. So we used to differentiate x, then we used to differentiate 1. Okay. Like that only we will integrate like this. So this is integration of x dx minus integration of 1 dx. What is integration of x? Anybody? So ma'am, it is going to be just add one power. Remember x power n plus 1 upon n plus 1. So x square upon 2 minus integration of 1. What is 1? X power 0. So x power 0 plus 1 upon 0 plus 1. So x power 1 upon 1 plus c. So this is going to give you x square by 2 minus x plus c as the final answer. Tell me, is it difficult? Is it easy? Give me thumbs up so that I can move on to the next problem. Okay. Chalo. Now what is this question? This question looks like, ma'am, is it, oh, algebra and trigonometry together. Algebra and trigonometry together. X square plus sine square x. Sec square x whole upon 1 plus x square. Okay. See, right now algebra and trigonometry together, it will be very difficult. So we need to separate algebra and trigonometry. That's the first thing we need to do. Let's separate the algebra and trigonometry, okay? So what we are going to do is x square. Sine square x, can I convert this? Plus 1 minus cos square x. This is x square plus 1 into sec square x dx. Okay. X square plus 1 upon x square plus 1. So x square plus 1 upon x square plus 1. It is going to be just 1. Minus. This is what? Cos square x upon 1 plus x square. Correct? And outside this we have sec square x dx. See, understand. Integration will be the last step. In my mind, just observe. I am integrating in the last as much as possible. I am first focusing on simplification. Now this is what? Sec square x minus multiplies cos into sec 1. So 1 upon. Can you see how beautifully algebra and trigonometry got separated? Integration of sec square x is what? Tell me. Derivative of tan x is sec square x. Derivative of tan x is sec square x. Integration of sec square x is tan x minus. I don't know, but how many of you remember? Okay, maybe I didn't tell you. No, I did tell you. Remember, I told you that derivative of tan inverse x, although I am going to give you formulas also. One more time, don't worry about it. But derivative of tan inverse x, can anybody remember? 1 upon 1 plus x square. So integration of 1 upon 1 plus x square will be what? Tan inverse x. Do not panic if you do not know this, because we are going to focus on trigonometric integration also, in ITF, in integration of ITF also. Right now, just remember it. Okay? Yes? Clear? Explain 3-step. Okay. The very first step was, see, sine square x, I noticed now. So I was like, this 1 plus x square. 1 plus x square. Can I get 1 plus x square in the numerator? That's what my concern was. If I get 1 plus x square in the numerator, then what can happen? I can separate and 1 plus x square can get cancelled out. That's why I thought that, okay, yes, I can get very easily. Sine square x is nothing but 1 minus cos square x, and in such a way I will get x square plus 1. Okay. So now what we need to do is, we need to separate x square plus 1 upon x square plus 1. Okay. It will become what? 1. Then cos square x upon x square plus 1 as it is, and sec square x is already outside. Now I have just multiplied it. Sec square x into 1 and sec and cos will become, product will become 1. So only this 1 plus x square will be left out. Done, done, done. Yes, Vidul? Clear? Okay. Chalo. Now I want you to do some questions. Okay. Let's see how many of you can do this question. Hint is already written. Okay, so 1 upon x root x, x power minus 1, x power minus half, integration dx. So that means x power minus 3 by 2 overall. Okay, so x power minus 3 by 2 plus 1 upon minus 3 by 2 plus 1 as per this formula. Now just solve this. Minus 3 by 2 plus 1. So this is x power minus half upon minus half plus c. So this is minus of 2 by root x plus c. Yes, absolutely. Clear, clear, clear. I think somebody is missing negative sign. Who is missing negative sign? Vidul, what happened? What happened? Chalo. Next question. Quickly, quickly now do it. Cos square x by 2 minus sin square x by 2. Okay, so that is a direct formula. This is actually integration of cos x. And this is the direct formula. Now the answer will be sin x plus c. Do not get confused. Sometimes what happens now, we mix up things. We think that, okay, derivative of cos x is minus sin x. We get confused because derivative integration. Two things are there, no? Okay, chalo. So, right till now, what we have done is, we have realized that how just by a couple of formulas and just by knowing the definition, the antiderivative, we can actually find the integration. Okay, this is something which are basics, and these basics, like, this is a common sense. Sometimes we are going to, in this whole lecture, we are going to learn a lot of techniques for integration, like substitution, by parts, partial fraction, putter, miscellaneous. So many techniques we are going to learn. But make sure that you do not forget the basics. Sometimes what happens is we learn so many techniques, we see a question and we feel like how to do this question, by substitution, by parts, by this, by that, and eventually some questions are very simple, and in between some questions also this thing may be utilized, that okay, I want to know integration of this particular part. So I know the definition integration is antiderivative. So if derivative of that I know, the integration of reverse I can know. Okay. So now today's session, overall we are going to go like this. The indefinite integration, basic, like the flow of indefinite integration will be like this: substitution, by parts, partial fraction, and then miscellaneous problems. Okay. Today we are going to target substitution. Okay, and substitution method is something which you're going to absolutely enjoy. Okay, so yes, what is substitution? Let's understand. Substitution means that suppose you need to integrate a function like this. Okay, f of g of x dot g dash x. So what you will do is you will put g of x is equals to t. Substitution, putting t is substitution. The moment you put g of x is equals to t, what will you do? You will differentiate both the sides like this. So g dash x dx will become dt. So g dash x dx will become dt, and this is f of t. Can you see this whole integration converted with respect to t? Now you can easily integrate f of t. Obviously, we are going to learn by the basic example over here. Can you see this type of question? Okay. So obviously the internal, this is a very standard function. I mean, see, the very obvious choice, the very first thing in human brain in a JEE aspirant will be, can I do this question by substitution? If you're not able to do it by substitution, then you will think about, okay, by parts, partial fraction, whatever. Okay, very first thought will be substitution. Now, what to substitute? That's the question. But you know what? It is so obvious. There are very few functions. You tell me now. Which thing should be substituted as t? Obviously, log x. Put log x is equals to t. Now, differentiate. Derivative of log x is 1 by x. Dx is equals to dt. So, dx upon x is gone. Dx upon x is gone. So this is cos of log x is already t and dt. Integration of cos t. You know that. Ma'am, integration of cos is sin t plus t. But you know what? Never leave your answer in terms of t. Because t is your variable. T is not your question given variable. Your assumed variable. So sin of log of x plus c will be your answer. Are you getting it? Are you understanding it? If yes, then we can move forward and solve a couple of questions on substitution. Ready? Ready for substitution? Chalo. Quickly, fastest fingers first we need to do. Chalo. X cube dx upon 1 plus x power 8. Ooh. Twist. Little twist is there. Little twist is there. Write the substitution. Write the substitution. See, understand now. What should you substitute so that on differentiation, your remaining thing with dx should get created. Understand, in previous question, we put log x is equals to t, and that's why what happened was 1 by x dx was automatically created. Okay. Now Gokul Raj is saying, ma'am, put x square is equals to t. Let's see. See, first suggestion is Gokul. Gokul is saying x square is equals to t. What will happen? 2x dx will become dt. So, you know what? I mean, can be done, but you know what? Not very appropriate. You will need one more iteration for that. Okay, not absolutely wrong, but I won't say this is absolutely on point. So, this is incorrect. Now, the second suggestion Muskan is giving, that ma'am, put x power 4 is equals to t. See, you have to hit and try. Automatically your brain will get connected. Okay, this is working for me or not. 4x cube dx is equals to dt. Absolutely, you should go for it, because you know what, this x cube dx is getting created now, overall complete. Okay, so this is going to be integration x cube dx will be what? Dt upon 4, and this is 1 plus x power 8. X power 8 will be t square. Remember, I just told you about the integration of this tan inverse x, tan inverse t. So 1 upon 4 tan inverse t plus c, and t eventually will be replaced by what? X power 4. Okay, getting it now? Okay. So see, Gokul, there is nothing wrong, and other people who are trying also. See, just put and understand that what exactly you are going to get over here. Okay, keep it aside. That okay. Can I do a little bit better? Think about something else. This worked, so discard this. If that will not work, what should you do? You can stick to the previous thing. So you have to hit and try. Okay, your copy should look like that. Yes, you are solving integration, you are thinking, you are discarding, you are rethinking, you are accepting, like that. This is the whole process. Okay, yes, do not hesitate in doing wrong also. 1, 2 substitution, wrong substitution will be fine, no worry. Now log of x plus square root of 1 plus x square. What should you put? T. What should you put? T. This is interesting question. See, if you're going to put this as t, it is so obvious that you cannot get this after differentiating this. See, Vidul, yes, Vidul is saying that ma'am, put this as t. Okay, there are only 2 choices. See, I don't have much choices over here, either this or this. But if you do this, what will happen? 1 upon 2 root 1 plus x square, 2x is equals dx is equals to dt. I don't think so it is helping me. Are you, like, other things should absolutely be gone, like that. So it, I mean, what are you going to do? Log of x plus t. See, it is not working, no? It is not working. X t mixture. Okay, so wrong approach. Why? Because see, log, inside the log there right now, if you do that now, what will happen inside the log? This will be t, this will be t, fine. But what about this x? Your expression should be completely in terms of t. Then only it will make sense, otherwise not. So I think this is a wrong approach. Okay, now next, what should you do? I think the next obvious choice will be that take log of x plus root 1 plus x square is equals to t. Now differentiate. What will you get? If you differentiate, what are you going to get? Okay, let's see. 1 upon x plus square root 1 plus x square. Okay, multiply, chain rule. Now inside function will be differentiated. So x will be differentiated. It will be 1 plus 1 upon 2 root 1 plus x square, and here you have to multiply it with 2x. Chain rule, na? Dx is equals to dt. Okay. 2 cancel. 2 cancel. Okay. So it is 1 upon x plus square root 1 plus x square. What about this? If you take LCM, 2 anyway cancel. It is going to be square root 1 plus x square plus x is already there, and in the denominator already it was present. Okay. Dx dt. I can clearly see that this is going to get cancelled out. So 1 upon square root. Can you see? This thing is only left out. This will be replaced by dt. And log this is t. Can you see how simple the integration became? I mean the main steps. Can you see the main steps? Main step is two-step process. Side processes, when side character becomes main character. है ना? Right? So now t square by 2 plus c. And what is t square? T square means log. So it is log of square x plus square root 1 plus x square. 1 by 2 is also there, plus c. This is the final answer. Have a look, let me know. Clear? Any doubt? You can ask me. Yes, this square, no, it is on log. So if you don't want to apply the square over here, then what you can do is you can apply the square on here. But please do not apply the square on this thing. Square is not over here. Yes. Okie dokie. Next question. Tell me. So we are actually, what are we doing? We are learning what to put t. What to put t. We are learning. And what not to put t. How to put t. Okay, how to substitute basically. Okay, so Vidul has given the answer. Put x cube is equals to t. Anybody else? Put x cube is equals to t. Yes, this is correct. This is not wrong. Okay, so you do it. Yes, now Zisha is saying, I think so many of you are saying x cube, but Zisha is saying, slightly better. Okay, slightly better. In this, what Zisha is telling you now, tan inverse x cube if you put t, then what will happen? Only one substitution will be there. But if you put x cube is equals to t, what will happen? Then again you have to go with like double substitution. Okay. So see, tan inverse, I will show you. See here. If you put x cube is equals to t, that is also not absolutely wrong. I mean, the only thing is that it will take a little more steps. That's it. Okay, easy only. So ma'am, 3x square dx is equals to dt. So let's do it. Integration will be what? X square dx. X square dx will become what? Dt upon 3. Okay, now tan inverse t, because see, tan inverse t whole upon 1 plus t square. Now one more time, you have to put what? Tan inverse t is equals to a. So 1 upon 1 plus a t square will become what? Dt will become dA. Okay, so now this will become dA. Okay, so finally it will be dA. So 1 by 3 a dA. It is going to give you what? A square by 2. So a square by 6 plus c. And then eventually you put, what is a tan inverse t? What is t? Eventually you can do. Okay. Now what will happen if you directly put x tan inverse x cube is equals to t. Okay, so what will happen? Tan inverse, ma'am, derivative of tan inverse will be 1 upon 1 plus x square. So this is x power 6. And then chain rule. Chain rule. Derivative of x cube will be what? 3x square. Dx is equals to dt. Okay, this 3 will go here. So understand now x square dx and this, all 3 will be gone. All 3 will be what? Dt by 3. So this is dt upon 3 tan inverse x cube this. Okay. So this is t square by 6 plus c. Finally the answer will be what? Tan inverse x cube whole square upon 6 plus c. Got it? Yes? Shall I give you the next question? Next question ready? Next question ready? Ready? Okay. Again, now dual substitution. Okay. So think about that. Okay, what can I put? The very first choice will be what? Root x. Root x is equals to, important for your CBSE also, sometimes they give you if you put tan root x is equals to t, derivative of tan x is what? Sec square x. Sec square root x. Now chain rule. Derivative of root x is 1 upon 2 root x. Dx is equals to dt. Understand now, sec square root x upon root x into dx will become 2 dt. And this is what? T. So 2t dt integration. So this is what? T square by 2 to cancel. So eventually t square plus c. What is t? So tan square root x plus c, everybody. Gokul, why are you saying tan inverse t? Inverse is not required over here. Anyway, moving on to the next problem. Are you ready to tell me what to put t? What to put t? Okay. So Vidhul is saying tan inverse x ko you can put t. Let's see what happens. So 1 upon 1 plus x square dx is equals to dt. So see, this is gone. This has become dt. This is cosec t. Integration of cosec is what? Integration of cosec minus integration of cosec x is what? That I have not taught you. No, no, I didn't teach you. So leave it here only. Keep it till here. Okay, chalo. Next question. Integration of cos 2x upon sin x. Okay. First of all, simplify. See, cos 2x is 2x. Sin x is single x. So why don't we convert this? So cos 2x is what? In terms of sine, let's do. In terms of sine, it is 1 minus 2 sine square x upon sine x dx. Okay. So integration of again cosec x, cos square x. Okay, I think these two questions now, I think not, we can't do it right now because we don't know the integration. We'll do it later. Okay. Let's talk about the next question. Chalo. Now let's do some MCQs. Let's do some MCQs. ln x whole square by x dx. Substitution. What are you going to put? Vidul is saying B, Gokul is saying B. Okay, let's see. So log x you need to put as t. Okay. So 1 by x dx is dt. Dx by x is dt. Integration of t square dt. T cube by 3 plus c. Right? So log of x whole cube by 3 plus c. Option B. Okay. Yes. Ready for the next question? Chalo. Next. What will you put? Tell me. X power 4 is equals to t. 4x cube dx is equals to dt. X cube dx is equals to dt upon 4. Okay. So x cube dx is equals to dt upon 4. So sine t dt upon 4. Integration of sine is minus cos. So minus cos t. T is x power 4 by 4 plus c. Option B again. Yes. Chalo. Next. Okay. Now some formulas we need to remember, and we are going to prove also. Integration of tan x. Now remember it. Integration of tan x is log of mod of sec x. ln sec x. Mod you will remember. Integration of tan is what? Log sec x. How? First of all, just convert it into sine and cos. Now put cos x is equals to t. Cos x is equals to t. So minus sin x dx is going to be dt. Sin x dx is going to be minus dt upon t. Now tell me, integration of 1 by t. Integration of 1 by t. Remember the formula, 1 by x integration is log x. So minus log of t plus c mod t. Okay. So now minus sign, remember the property of log, minus sign will go in the power of t. So it is going to be log of 1 by mod t plus c. Here t is cos x. So log of 1 by cos x sec x plus t plus c. Okay. In similar manner, this is your DIY homework. Prove integration of cot x. Now integration of cot x. Now remember, see how to remember, I'll tell you. Tan x, no? So sine by cos. Okay. So cos, log of reciprocal of cos. Log of reciprocal of denominator. Here cos by sine. Okay. Denominator is the key. Cot is what? Cos by sine. So log of denominator directly. Here log of reciprocal of denominator. Log of just denominator. Okay. Yes. Now this question. Integration of sec x. Now this is important for your CBSE also. Sometimes they give you as a proof. Very important. Integration of sec x. Okay. Why this is important? Because in here, this is not a direct question. In fact, you have to multiply. You have to multiply and divide by sec x plus tan x. Multiply and divide by sec x plus tan x. Sec x plus tan x. Because right now in the original state, so you can't integrate it. You can't put anything t. You will not get it, even if you're going to try. Okay. Multiply sec square x plus sec x tan x whole upon sec x plus tan x dx integration. Now put sec x plus tan x as t. Sec x plus tan x, let's put as t. Now differentiate. Ma'am, derivative of sec x. Derivative of sec x is sec x tan x. Derivative of tan x is sec square x. Dx is equals to dt. Can you see the numerator part is becoming dt and denominator is becoming just t. So this is going to be log of mod of t. What is t? What is t? Sec x plus tan x plus c. Okie dokie. Yes. And this sec x plus tan x also can be written down as 1 plus sin x upon cos x. Okay, 1 plus sin x is nothing but cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2. Directly I can write 1 minus tan x by 2 whole upon 1 plus tan x by 2. Solve it. You know trigonometry, right? 1 minus tan x by 2 whole upon 1 plus tan x by 2. And this whole thing, do you remember? Tan pi by 4 plus x by 2. Okay. Now you know what? In similar manner, this is again DIY homework. Cosec x. You need to multiply cosec x minus cot x in the numerator and denominator. Denominator put it as t, just like this. We did this now. Same. Just multiply cosec x minus cot x in numerator and denominator. Again, same thing will be happening. So just remember these two formulas. This and this also, this and this also. Now you'll be wondering that, ma'am, how to remember so many formulas? Yes, there are so many formulas. Number one, how to remember, understand, learn, read the proof, but then practice. And we are going to do that. Okay, the moment you start applying things, things will start falling into the place. Okay, now some basic rules of integration. I don't know whether I need to tell you or not, but while differentiating also we use the similar rules, that if at all any constant is there, the constant will come out and just integrate fx. If at all there are 2, 3 functions sum, we have already used this rule, applied this rule. 2 functions are in sum or different, just integrate it separately. That's it. Okay. So just these 2 questions I want all of you to do with me, obviously. So integration of this, it will be integration of 4x power 5 plus integration of root x. Dx is already there in both. Okay. If you do forget to apply dx individually, your marks will get deducted. But obviously in JEE Main, no marks deduction if you do not apply. But in CBSE, in board examination, it can happen. So just power add and this. Root x. So this is going to be x power half plus 1 upon plus 1. X power 3 by 2 and here 3 by 2. 3 and this is 2 plus c. And this is also 2 by 3. So 2 by 3 you can take common just to simplify, x power 6 plus x power 3 by 2 plus c. Okay? Yes? Next question. 2 by 5 power x. Remember a power x. Remember the formula a power x. First of all, separate out the integration a power x. So, ma'am, integration is 2 by 5 power x upon ln 2 by 5 minus 3 by 5 power x upon ln 3 by 5 plus c. Okay. Now one MCQ, I will give it to you. Solve it. And will be sometimes, you know what, options also tells you a lot of things, that okay, Option is ln mod tan. Okay. Try. So see, cos x plus root 3 sin x. This expression only. Trigonometry, if I taught you, you need to divide and multiply by square root of a square plus b square. Do you remember? Basically, you need to multiply and divide by 2. So 2 will remain outside and 1 by 2 and root 3 by 2. So this is 2. Now this 1 by 2, this 1 by 2 will become what? Cos or sine? What do we want? Cos or sine? Cos 60 degrees. So cos 60 degrees cos pi by 3. Not really. We want sine 30 degree. Yes, better. Sine pi by 6. Okay, and this is cos pi by 6. Correct or not? So sine A cos B plus cos A sine B. So this is what? Sine pi by 6 plus pi by 6 plus x. Okay. Basically, this is nothing but dx upon 2, and this is sine in the denominator. In the numerator, it will become what? Cosec. Oops. I still did not. Hey, we just actually, so this is cosec and x plus pi by 6. Correct or not? Dx. And we just saw, can you see, if I go back, integration of cosec x, we just saw. ln directly this formula, ln mod tan x by 2. ln mod tan x by 2. Integration of cos is nothing but ln. So 1 by 2 is there. ln mod of tan x by 2. Here x is this whole thing. So divide by 2. Tan x by 2. Here x is this whole thing. So x by 2 plus pi by 12 plus c. Can you see which answer is matching? Tell me. Option A? Yes. C is wrong because half is not there. D is also wrong. Minus sign, so B is rejected. Only A option is absolutely correct. Okay, yes. Slightly it is tricky. That is why we will need a lot of practice in indefinite integration, but do not worry. So if you put sine theta over here, no formula will get created. If you put cos theta, a square plus a square, 1 plus cos square theta is no such formula. 1 plus tan square, 1 plus cot square. Only two formulas are there which will work for the first expression. Okay, so it depends on the expression that what exactly you're going to put. So you have 6 trigonometric ratios, and if I talk about primary ones, sine, cos, tan. Think about what formulas do you have. Okay, so a square minus x square. Now sine theta or cos theta will come to the picture. Now x square minus a square. So put sec square minus 1 will make sense. So sec square minus 1 or cos x square minus 1. You remember the three identities, right? And now when this is important, when you have both a minus x and a plus x together, so for that you have to put a cos 2 theta because of the two gold formulas. Remember, 1 plus cos 2 theta is 2 cos square theta. So whenever you put x is equals to a cos theta, what will happen? A plus a cos 2 theta, a will come out. 1 plus cos 2 theta, you can apply the formula and eventually it can come out from the square root. Okay. Two gold formula. Remember everybody, these two are very important formulas. Okay. Yes. All right. So obviously we'll solve some problems, then only you will be able to understand. For example, integration of this. Now I don't know how many of you know, but what is the derivative of sine inverse x? In differentiation chapter we have studied this. It is 1 upon square root 1 minus x square. Same over here. Can you see? Now integration, let's generalize this. So integration of this will be sine inverse. Okay. So dx upon square root a square minus x square is sine inverse x by a. Let's prove it. Okay. So whenever I told you now, this expression a square minus x square tells me that put x is equals to a sine theta. Now differentiate. Dx is equals to a cos theta d theta. Okay. So now integrate from here. Integration dx will be replaced by what? A cos theta d theta upon square root of a square minus x square. Okay. A square minus x square. X square is a square sine square theta. A square, if you take common, you will realize that a square will become a and it will become a cancel out. So 1 minus sine square theta is what? Square root of cos square theta, which is square root of cos square theta is cos theta. Cos theta cancel. So just d theta. So integration will be theta plus c. What is theta now? So ma'am, theta is x upon a and then sine inverse. So sine inverse x by a plus c. Let me know. Let me know. Is this clear? Give me a big thumbs up if this is clear. Okay? Easy, not very difficult. Now I will give you 3 important formulas based on this. First, you know, square root of a square. See, understand. Here there is no 1 by a over here. Some students get confused, and you know what? NTA plays on exactly that. They will give you an integration and they will write the answer also, and they will write that 1 by a sine inverse x by 3. Now what is the value of a? In sine inverse formula, there is no multiplication in the beginning, right? So make sure that you do not get confused. But you know what? In tan inverse formula, there is 1 by a tan inverse x by a. So this is your homework. Just prove it. Okay. Put x is equals to a tan theta. Then take common. What will happen? A square. It will come out. 1 by a square. It will come out. And it will be what? 1 upon 1 plus tan square is sec square. So integration of cos square theta. Like that it will go. Okay. and dx upon mod x square root x square minus a square is 1 by a sec inverse x by. Can you see? In fact, this formula also having 1 by a, this also 1 by a, but this is not having 1 by a. Okay, right? So this is how substitution works. Alrighty everybody, yes. Now just quickly solve a problem so that I can like understand whether you have got the gist of these problems or not. Solve it quickly. Elementary problem, huh? Let me adjust my hairstyle a bit. Perfect. You guys must be having, especially girls. You girls might be having that hairstyle, na? That one hairstyle which you make while you study, so that your hair doesn't irritate you. I also have a hairstyle. While teaching, I don't want anybody to irritate me. Okay. So integration of 1 upon x square plus root 5 whole square dx. Okay. So now you know the formula, 1 by root 5 tan inverse x by root 5 plus c. Easy? Yes? Now solve this. Okay. How will you solve it? See, 2 plus 5x square. Can I write it as 2 plus 2x square plus 3x square? See, you have to hit and trial. Now just divide it by x square 1 plus x square and x square 1 plus x square. Integration, integration. Okay, clearly 1 plus x square and 1 plus x square will be gone. This will be 2. So this is integration of 2x power minus 2 dx plus x square cancels, so 3 1 upon 1 plus x square dx. Okay. Now x power minus 2 plus 1. So this is 2 minus 2 by x plus 3 tan inverse x plus c. Easy. Only if you can like separate it out. This step is important. Then only you will be able to do it. Right or wrong? Yes? Next, next, next. Now see. Dx upon square root of a square plus x square. Another formula on your screen, okay? I know now today's session is going to be a lot of formulas, but you know what? I'll make sure that you remember it also. See, 1 upon x square plus x square, so you know now. You know that 1 upon x square plus a square is what? 1 by a tan inverse x by a. Now there is a square root over here. So the moment square root arrives, it will become log. Okay, so the answer is log of mod of x plus copy paste. Okay, do you want me to solve it? I can solve it also. Put x is equals to a tan theta. So dx will be what? A derivative of this is sec square theta d theta. So integration of a sec square theta d theta upon square root a square plus x square. So a square will come out, it will become a. 1 plus tan square theta is sec square theta. So sec square theta, so it will be what? A cancel, integration of it is going to be just sec theta. Now integration of sec theta, you know, log of mod of tan theta plus sec theta plus c. So log of mod of. Now understand, tan theta. Tan theta is what? Tan theta is what? X by a. X by a plus sec theta. So ma'am, sec theta will be what? Square root of 1 plus tan square theta. So 1 plus x square by a square plus c. If you solve it, it will go here. And you know what? Log a will be adjusted in constant. So log of x plus mod square root a square plus x square will be there. Here a will what happen? See, this is upon a. So log of something, log of, basically this is coming out as log of this upon a, right or wrong? Now we know the formula, right? Log a by b is log a minus log b. So this is minus log a. If you remove it, it will become minus log a, which is a constant again. So this is the answer. Yes? Okay. So it is not very difficult also if you forget the formula sometimes. I mean, don't completely forget it, but yes, if you are forgetting it sometimes, so you can actually think about it, how to do it. Substitution. See, here what you need to put, see, this is the formula. Now I think this is not going to be very difficult for you, because you know what? See, x square plus a square, this is x square minus a square. Same thing, log of mod of x plus copy paste. These two formulas are same only. You just have to remember the format. Log of mod of x plus copy paste. Okay. Now what about this? Dx upon a square minus x square. So the formula will be 1 upon 2a ln mod. Now see, understand. If you split this, what will happen? Ma'am, a plus x and a minus x. So a plus x upon a minus x mod close plus c. So that's how it is done. Okay. So remember these three formulas, because yes, we are going to apply these formulas. Okay. Now this. Find this. So very easy, ma'am. Log of mod of x plus square root x square plus 4 plus c. Done, done, done. Not a very difficult thing, right? Okay. All right. What about this now? Okay. E power x minus 1. Think about it. Think about it. How will you solve it? Just tell me what will be your first step. E power x upon square root of e power 2x minus 1 integral minus integral of 1 upon square root e power 2x minus 1. Okay. So e power, this is e power x square. So I am putting e power x is equals to t for this one. So e power x dx will become dt. So this is dt upon square root of t square minus 1. I think this we can do it, right? This is log of mod of t plus copy paste. Plus, what about this? Not plus. What about this now? Okay. So what if I multiply e power x and put e power x is equals to t? So e power x dx again will become what? dt, and this is upon t square root t square minus 1. Oops. Can you see? Can you see? What is this? This is sec inverse t. Sec inverse t plus c. Now just put the value of t, which is e power x, and write your answer. So log of mod of e power x plus square root of e power 2x minus 1, okay, minus sec inverse e power x plus c. This is your answer. Okay. All right. Yes? Clear? Chalo. Next question, let's say. Let's see next question. Now what will you put t? Quickly. Now it should strike quickly in your brain. Yes, Gokul. Put x square is equals to t, because then 2x dx will become what? dt. So over here, x dx will be dt upon 2. And this is what? Now x square is equal to t square minus 1. Okay, so 1 by 2. Okay. Now let me tell you, we remember this formula, 1 upon a square minus x square integration is what? Log of mod of a plus x upon a minus x. But you know what? Here things are slightly different. You need to take minus sign common, so that you get 1 square minus t square. And now you can integrate. So this is minus 1 by 2. Multiply, don't forget 1 by 2a. Multiply 1 by 2a. Okay. Now log of 1 plus t upon 1 minus t plus c. So this is going to be 1 by 4. But you know what? This minus sign. So this minus sign, I will remove it from here, apply it here. So it will be minus 1, reciprocal of it. So 1 minus t will come over here, log. Log of 1 minus t upon 1 plus t plus c. So this is 1 by 4 log of mod of 1 minus x square whole upon 1 plus x square plus c. Okay? Yes? Yes, actually you can, So this is the answer, right? Okay. Now, see, remember that chart we have seen in the last class where we saw that techniques of integration. Number 1 was substitution. Then the second one was by parts. The third one was partial fraction, and the fourth one was miscellaneous and putur. So now we are going to focus on by parts today. Okay. So by parts, majorly we are going to go about by parts, and let's see if we can do partial fraction today or not. Let's see that. Okay. Yes. So now u and v are two functions of x. Integration of u and v. So when there are two functions, you know how to differentiate that. Now you have two functions, you should know how to integrate that. So what will you do? First of all, you will decide which one is going to be the first function, which one is going to be the second function. Okay? Like differentiation it doesn't matter. First or second doesn't matter because it's symmetric. But in here, deciding on first and second is different. Okay, the answer will be completely different if you decide that this is my first function, and answer will be completely different if you decide my second function is this. Okay, now how to decide that we will see, but right now let's see the formula. Integration of first and second is equals to first function constant integration of second. First function constant integration of second minus integration of derivative of first. See, whatever you have written constant over here, now you have to differentiate that and then multiply, you have to integrate the second function. And overall the combination eventually you have to integrate. Okay, we'll do it, we'll understand it, then only you'll be able to learn this. But ma'am, how to decide? How to decide on first and second function? For that we have Eilert rule. Okay, Eilert rule says that the preference will be given in this order. The first priority will be ITF. So whenever you see two functions and you see sine inverse x or cos inverse x or tan inverse x, mark this as first function. Then logarithmic, if you see, okay, so logarithmic and algebra. Logarithmic will be first and algebra will be second. Okay, so in this exponential will be the last, Eilert. Okay, so inverse, ITF, logarithm, algebra, trigonometry, exponential. Okay, function which comes later is taken as integrable. Now why it is happening? Because see, inverse trigonometric function, we do not know the integration of sine inverse x. Do we know? No. Have we seen any formula? No. We have no formula for integration of ITF. We have no formula of integration of log x also. But we do have formula for e power x. We do have formula for normal trigonometric function like sin x, cos x. So if you see, the second function is actually, we need to integrate the second function in this formula. So basically think about this, think about this way also, that the second function should be integrable and first function is something which we find difficulty in integrating. Okay, alright, so let's do one question. Chalo, let's do this. X tan inverse x. Obviously the first function will be inverse and the second will be this. Now what is the formula, ma'am? The formula will be first function constant integration of second minus first function constant integration of second minus minus 1 by 2 if I keep common. So what will happen? This is x square upon x square plus 1. So what I'm going to do is I'm going to add 1 and subtract 1. And you know what? You have to integrate this. Adding 1 and subtracting 1. So this is x square by 2 tan inverse x. Slightly lengthy process, but x square plus 1 cancel, so it will be 1. Minus half is already there. So minus half integration is x by 2. Minus plus. See, understand. Minus plus 1 upon x square plus 1 integration is tan inverse x plus c. So now this is your answer. Match it. X square by 2. So ma'am, B and D is wrong. There is no x square by 2. B and D is wrong. So x square by 2 tan inverse x minus x by 2. Acha, let's not forget half is also there. No, this half will get multiplied. So half is there. Option A looks correct. Have a look. Let me know. See, I'll write the formula first function constant integration of second minus integration of derivative of first and integration of second and the whole integration. Clear? Yes? By parts? Not very difficult, right? Chalo. Ninja technique coming on your way, by the way. X square sin x dx. Do we have let's do this first. Integration of log x. Now ma'am, we don't know this formula, integration of log x, and there is only one function. So by parts is also not applicable. Islet में L logarithm is coming on the second number. Okay, so what we are going to do is, we don't know the formula, so we will just multiply it with 1 so that this becomes first function and this becomes second function, and now apply the formula. What is the formula, ma'am? First function constant. Okay. Integration of second function. Okay. Integration of 1 is x minus integral of derivative of first function. Okay. Integration of second. Okay. So this is x cancel, this is 1 only. Right or wrong? See. X cancel. So this is going to be x ln x minus, now integration of 1 is x plus c. And I have to remember it, x log x minus x. X log x minus x. So integration of log x, remember it, x log x minus x. Log x is such a important function, you should remember, even if this is not a formula, but you should remember it, x log x minus x is the integration of log x. Okay, alright, yes. Now one question I will give you, and this was asked in JEE Main January 2019. Slightly tricky, but not that tricky. Okay. First of all, the moment you see this question, what strikes in your brain? Tell me. See, the very first preference of every JEE aspirant and every maths teacher is also that I don't want to use by parts. If at all I can use substitution, then I will go. That is my first preference. Yes or no? Substitution was much easier. I mean, by parts is also not very difficult, but still substitution is something which comes with very ease. Automatically things fall in place. So right now, can I do it with substitution? Let's see. So if I put minus 4x cube is equals to t, what will happen? So ma'am, it will be minus 12x square dx will become dt. Okay. So x square dx. Now understand, I am going to write x power 5. X power 5 will be what? X cube, x square and e power minus 4x cube dx. Okay. So here x cube will be what? Minus t by 4. Minus t upon 4. Okay. X square. What is x square? In fact, x square and dx together will become dt minus dt upon 12. Okay. And. One more thing. We have, can you see this e power t? E power t is also there. So finally, what do we have? 1 upon 48. Integration of minus plus t e power t dt. Now this is much easier. This looks much easier, right or wrong? T e power t. So Islet rule, exponential will become last. So this is my second function, this is my first function. Now 1 by 48 is there, it is there already in the function also. Start integrating. 1 by 48 I will keep outside. First function constant, integration of second function minus integral of derivative of first. So derivative of t is 1 and integration of second e power t dt. So 1 upon 48. Now start putting the value also. T. What is T? T is, ma'am, minus 4x cube e power minus 4x cube minus integration of e power t is e power t only, minus 4x cube plus c. So now if you can take common also, e power 4x, if you can take common this and this, so it is going to give you what? 1 by 48 e power minus 4x cube, inside the bracket we have minus 4x cube minus 1. Okay, so this, if you compare, fx is actually matching with this or not? So B option is absolutely correct. Not a very difficult question, is it? Is it difficult? Okay. Now this question. Sometimes what happens if you apply by parts? What will happen? You are going to stuck in the same loop. See, this is out of integration also. How many of you feel that it happened with me, that we start a question and then eventually I made a shorts also out of that, 16 minus 9, 4 square minus 3 square, 4 plus 3, 4 minus 3, then multiply, then cancel, again 16 minus 9. Oops. Basically, we completely solve it and we get the same thing or sometimes similar thing also. So if we feel that all of that which we have solved, we are stuck in the same loop. Okay, but not exactly same. This is not exactly same, but you know what? You start solving it, you will realize that okay, it is happening. Let's see, solve it. X square sin x. Now I late. So I think first function is algebraic and second is sin x. Now apply the formula, ma'am. First function constant. Integration of sin x is what? Minus cos x. Minus integration of derivative of first function. And integration of second will be what? How many of you actually are getting this? Is it difficult or am I applying too fast? Am I applying the formula too fast? That also tell me. Are you able to do that with me? Okay, so now again, can you see you are stuck in that same by parts thing? Algebra and trigonometry together, by parts is the thing. So now again, this is your first, this is your second. So it is going to be x square plus. Now first function 2 is already there. First function constant, integration of cos x is sin x. First function as it is, integration of second minus integration of derivative of first and integration of second. That's it. So finally what will you get? Not here. Minus x square cos x plus 2 x sin x minus, now sin x integration is plus cos x plus c. This is your answer. So minus x square cos x. So I think this and this. B option is wrong. Plus 2x sin x. So I think B and C both are wrong. Plus 2x and plus cos x. Option A is absolutely right. Yes, this is a normal method, but are you interested in ninja technique? Okay, in that case what you have to do is ninja technique. It is applicable, see, it is applicable when you have actually, when the recurring by parts is there. This is of the type recurring by parts, multiple. Now imagine This is the x square. So you were stuck in only one loop. But suppose it is x cube, then what will happen? So ma'am, if at all it is x cube, then the answer would be here it will be 3x square. So x square cos x. One more step it will take, here it will be x sin x, one more step. And imagine if it is x power 4, 3 loop, x power 8, multiple loops. Oh my god. Then the x power 8, so you won't be able to solve it. You will take 15-20 minutes. More than that, you will be exhausted. Okay. So in that case, what you need to do is, you need to use DI method. What is DI method? DI method mein, you have to keep that x square as it is. And you need to integrate sin x. Okay, ma'am. Integrate sin x, ma'am. Integrate sin x is minus cos x. Okay, the first is plus sign. Now apply the negative sign over here, and now you just differentiate x square, which is 2x. Okay, so d. And integrate minus cos x. If you integrate minus cos x, tell me, this is I. Integration of minus cos x will be what? So ma'am, integration of minus cos x will be minus sin x. Again di. 2x है ना, तो अभी देख see plus then minus, this sign will be plus now. Then again d. So derivative of 2x is 2, and integration of minus sin x is minus cos x, so it will be plus cos x. Okay, and after that what will happen? You have to differentiate 2, which is going to be 0. So that's it. We are going to stop it over here. So answer will be what? X square minus x square cos x plus 2x sin x plus 2 cos x. Can you see? DI method. X square kept as it is, sin x got integrated. Now what will happen? X square will be differentiated 2x, 2x will be differentiated 2. Minus cos x continuation integration, minus cos x integration is minus sin x integration is cos x. Getting it? Getting this ninja technique? Don't worry, because we have more questions. We'll be doing more questions on ninja technique also. Okay? But for now, let's do this question. JEE Main September 2020. Integration of sine inverse square root x upon 1 plus x. Okay. Try. Okay. So now, see, for sure there is going to be a trigonometric substitution in it. How many of you understand it? For sure. Right now you cannot even integrate. In fact, sine inverse integration, so you don't know. You have to substitute something which is trigonometry over here. Now 1 plus x. You have to substitute such value or such trigonometry thing so that both x and 1 plus x will get free from root. 1 plus x. So suppose you put x is equals to tan square theta. Then what will happen? So ma'am, dx will become what? 2 tan theta sec square theta d theta. Integration of sine inverse square root x is what? Tan square theta. So square root of tan square theta will get free. 1 plus tan square theta. Okay, dx will be what? 2 tan theta sec square theta d theta. Completely in terms of theta now. Okay, so what is this? Integration of sine inverse Now this is tan theta upon sec theta. Tan theta upon sec theta is what? Tan upon sec is tan into sec. Sorry, tan into cos. This is sin theta. So sin inverse sin theta. Okay. Then we have 2 tan theta. So this is 2 sin theta. Sorry, this is going to be, understand. Tan is what? Sin by cos. Okay, and this is, oops. So this is going to be 2 tan theta. Okay. Let it remain as it is. 2 tan theta sec square theta d theta. Okay. So this is going to be what? Integration of theta. 2 is outside. Then we have theta is there. Okay. Then we have tan theta, or we can write sec theta. Sec theta, then we have sec theta, tan theta. Okay. D theta. Okay, now things are little complicated over here. Not that complicated actually, not complicated, it's tricky. Now obviously by parts will be there because see, theta is an algebraic function. X sin x. X is algebra, sin x is trigonometry. Theta sec theta. So theta is algebra. Okay, isolate. So this is going to be your first function. But who is going to be the second function? And you know what? Second function integration you should know. So that means, ma'am, do we know the integration of this second? If I assume that this whole thing is second, do I know the integration of this? Sec theta, tan theta. Let's see. So we need to find the integration of sec theta, tan theta, d theta. Let's see. Do we know if this is my second function? Then there is a multiple usage. Okay. So if I put sec theta as t and sec theta d theta will become dt. So yes, now we can integrate it, t square by t. So sec square theta by 2 is the integration. How many of you are getting it? Very interesting. So whenever this is the second function and whenever we need to write the integration of second, what are we going to write? Sec square theta by 2. Okay, so in that case, 2 is already outside. First function constant. Integration of second function. Ma'am, sec square theta by 2. Okay, minus integration of derivative of first. Derivative of theta is 1 and integration of second, sec square theta by 2 plus c. Yes or no? Am I doing anything wrong? Okay, this is correct. Sec square theta is there, na? So, if I put sec theta, what is derivative of sec theta? Sec x derivative is sec x tan x. So this is t sec square. Okay. So now 2 is getting cancelled out. So now the answer is theta sec square theta minus. What is this? Integration of sec square theta. Integration of sec square theta. Do we have any formula for this? No. Integration of sec square theta minus integration of sec square theta. How to integrate this now? I think will be done once we are able to do that. Sec square theta is 1, this is 1 plus tan square theta. So, integration of tan square theta. Yes, integration of sec square theta is what? Tan theta, na? So, theta sec square theta minus tan theta. Absolutely. That's it. Done, done, done. Okay. So, now this is your answer. Theta. Let's change it now. What is theta? Theta is root x. See, from here I can write tan theta is equals to what? Root x. Okay. So, theta is tan inverse root x. Theta is tan inverse root x. So, here I am going to write tan inverse root x. Tan inverse root x. Okay. What is this sec square theta? See, sec square theta is nothing but 1 plus tan square theta. So, 1 plus tan square theta is, so this is 1 plus x. Yes? Okay. So, theta is tan inverse x, tan inverse root x. Sec square theta is 1 plus tan square theta. 1 plus tan square theta means 1 plus exactly x. Okay. Now, minus tan theta. So, minus what is tan theta? Root x. Plus c. This is your answer. Now, compare. See, this and this are exactly same. So, your A is nothing but 1 plus x. What about B? B is minus root x. So, 1 plus x and minus root x, option B is absolutely correct. Yes? Okie dokie? Clear? Good question, right? Now, how to integrate sec cube x? And this is a recurring model. That means what you have to do is, sometimes, again I told you now, you start with something and you get the same thing. Okay. So, let us start at sec cube x. So, what I am going to do is, sec cube x can be written down as sec square x, sec x dx. Okay. Sec square x. What is sec square x, ma'am? 1 plus tan square. So, 1 plus tan square x and sec x dx. Yes? Actually not like that, sorry. Yes, here only we should think about putting first and second function. Now understand, we just did, by the way, the integration of sec square x is tan x. So, we know the integration of this, so it will be second, and we don't know the integration of sec x. I mean, we know, but sec square integration is much more easier to us. So, that's how it is. Now, apply by parts. So, I is equals to, let's assume that this is your I integration. I is equals to first function constant, second ka integration is what? Tan x. First function constant, integration of second function minus integration of derivative of first function. What is derivative of sec x? Derivative of sec x is sec x tan x. Okay. And integration of second will be just tan x dx. Okay. Alright. Now this is what? Tan square x. Can we do something about it? So this is sec x tan x minus. This is sec x and tan square x. What is tan square x? Sec square x minus 1. Okay, now if you solve it, do you even realize that what is going to happen? Sec cube x. So minus sec cube x, which is the original question. So can I write minus I minus plus integration of sec x dx? Yes? So I plus I. Now what will happen? 2i. So whenever, see, exactly same, you started solving it and eventually you realize, oops, to solve this I need to have I only. Okay, see, this is I only. You require integration of sec cube x to find integration of sec cube x. Funny, isn't it? But there is a technique. You write I and it will going to be 2i. This is sec x tan x minus integration of sec x. So we know log of mod of sec x plus tan x. Yes. So this is what we call as recurring model. Recurring model means that you start something and in between you get the same integration. That's a good news. That's not a bad news. You write it I and you get it. So that's why in the beginning only I assumed it as I. So please do not forget the last step because 1/2 should be there. Okay. So this is how it is. See, this is the answer. Clear? Sec cube x. So sec square was the second. Sec x and sec square x dx. First, second. First function constant, integration of second minus integration of derivative. So same thing. And then eventually I took it it is u here. So it is going to be like that. Okay. Do you want to try a question? Let's see. A JEE Main PYQ based on recurring model. Based on recurring model. I want all of you to try it. Now obviously 1 and dot. Okay, so this is first, oops, this is first and this is second. I is equals to first function constant, integration of second, minus integration of derivative of first function, derivative of cos. Derivative of cos is minus sine, so therefore sign will change, sine of ln x. Derivative of cos of ln x, right? So derivative of cos is minus sine, ln x is kept constant. Chain rule, log x derivative again because of chain rule, so log x will be differentiated 1 by x. Okay. Now integration of second, that means x dx. X constant. So I is equals to what? X cos of log x plus, can you see again similar, integration of 1 dot sine log x. That's how we are going to integrate. We are going to again apply by parts over here. Now in here this is second and this is first. I is equals to x cos log x plus ma'am trigonometric function cos of log x. This is what? Trigonometry completely. And I have told you also that, think about it, the second function should be that function whose integration should be known to you. The second function should be that function whose integration should be known to you. Do you know the integration of cos of log x? And this is a combined function. Okay. So yes, now again, sine log x is constant. Okay, and this is your x minus integration of derivative of first. So derivative of this now. So derivative of sine is cos. Don't forget 1 by x, and integration of 1 is x dx. Can you see this over here is nothing but I only, minus I. So it is going to be what? 2I is equals to x if you take common, cos log x plus sine log x upon 2, because this 2 will go out. So x by 2 cos plus sine, option C. Yes? Clear? Now understand, e power ax sine bx type of integration. Integration of the type? Ma'am, there you missed minus sign after differentiating cos of log x. No, I didn't miss minus sign, did I? I don't think so. Which minus sign? After differentiating cos. No, the minus sign became plus now. Minus is for formula, and then because cos derivative is minus sign, so I wrote plus sign. Correct, na? Integration of the type e power ax sine bx. Okay. Alright, so Eilert rule, let's apply. Eilert rule says that this is going to be the second function, this is going to be the first function. Sine bx constant, and integration of this, tell me, minus integration of derivative of first function. So b cos bx, okay, b cos bx, and integration of second, so e power ax upon a dx. Again, can you see? Again, similar type of e and cos, exponential cos, exponential and trigonometry is there. So this is I is equals to e power ax upon a sine bx minus b upon a, and you know what, again, this is going to be the first, this is second. First function constant, integration of second minus integration of derivative of first. So cos derivative is minus sine, a little bit lengthy, I know, and integration of second. Oops. Okay. Can you see again? This is same thing which we are trying to integrate. This is your I only. Okay. So I is equals to what? E power ax upon a sine bx minus b upon a square cos bx e power ax. Minus minus, minus plus minus, and you know what, this is b cancels, so just b upon a. This should be what? The derivative here. This is a, right? This is a. So now a square, b square by a square I. That's it. Okay, so if you solve it, I will come out 1 plus b square by a square, and you know what, if you take LCM, a e power ax sine bx minus b cos bx upon a square. See, I'll show you the final thing, which is this. See, it is going to be I and a square. A square anyway cancels. So a e power ax sine bx minus b cos bx, e power ax is already there. Okay, here also. Upon a square plus b square, correct? So this is how it is going to get. See, e power x, if you take common, this is how it is going to be. Lengthy, right? But yes, slightly lengthy, but you understand the process also. E power ax sine bx, e power ax upon a square plus b square, a square plus b square. Now a sine bx, b cos bx, a sine bx minus b cos bx. So this is how you need to integrate. These are the two formulas that you have to keep in mind. E power ax sine bx we just did. Now e power ax cos bx. Similarly, we'll integrate, we'll realize that okay, sine will become cos, cos will become minus sine. Not very difficult to remember, but yes, slightly lengthy. Do not worry. Solve a couple of problems, automatically it will come in your brain. Okay? Yes? Chalo. Now, if I give you one question, e power 2x cos x, will you be able to integrate that? Chalo, let's integrate. E power 2x cos x. So this is e power 2x will be common upon a square plus b square, 2 square plus 1 square. So 2 square plus 1 square, bracket. Now a cos bx, a cos bx. So 2 cos x plus b sin bx. So that means 1 sin x, just sin x. If you know the formula, can you see how easy it is? So this is how your answer will look like. Can you see? Yes? Clear? Give me a big thumbs up if you've understood it. Because now after this, a very important topic which we are going to study, both for definite and indefinite integration, this topic is very important. Okay? Which is nothing but two classic integral. Two classic integral. Two classic integral. Okay? Very easy also, but sometimes it might look a little bit tricky also. See, the formula says that e power x fx plus f dash x. E power x fx plus its derivative. If you need to integrate this, the answer is e power x fx. Now, what I'm going to do is, I am going to tell you this proof by reverse process. Okay, so can you just help me in differentiating this e power x fx? How will you differentiate this, ma'am? Differentiation, two product, easy. First function constant, differentiation of second plus first function, this time derivative. So e power x derivative is anyway e power x, and this time fx will be kept constant, right or wrong? So that means e power x f dash plus f. Okay, so derivative of this is what? E power x f dash plus f. So integration will be what? This. That's same as this. Integration of e power x f plus f dash is what? E power x into f. Okay? Yes. Now in this type of questions, now in these type of question, understand, you don't have to integrate, you don't have to differentiate, you don't have to do anything. You just have to focus on identification. 99% question is done if you are able to identify that. Okay, this particular question is from two classic integral, one of the two classic integrals. Okay, so over here I think this one identification is not very difficult. E power x is already there, so I am just looking for, inside the bracket there should be a function and there should be its differentiation. That's it. So ma'am, let's separate it now. X upon x square, ma'am, 1 by x minus 1 upon x square. Okay, dx. If this is your fx, if you differentiate with negative sign only, with sign you are getting f dash x. So yes ma'am, e power x fx plus f dash x, so we are getting. What is the answer then? The answer would be e power x into fx plus c. So e power x, identification is done, the 99% job is done, just put the value of fx. So this is your answer, e power x into x. Where are you? Hi. Sorry, into x nahi, upon x. fx is what? 1 by x, no? Option A. Okay? Clear? Chalo, let's do this question. Let's see how many of you can do this question. E power 2x, 1 plus sine 2x, 1 plus sine 2x, can I write sine x plus cos x whole square? 1 plus sine 2x is what? Sine x plus cos x whole square. And this is what? 2 cos square x. Okay? Yes or no? Gold. So e power 2x by 2 is already there, and you have sin x plus cos x upon cos x whole square e power 2x by 2 tan x plus 1, so basically 1 plus tan x whole square. So e power 2x by 2 1 plus tan square x plus 2 tan x. Is it making sense or not? I don't know. 1 plus tan square is sec square. Oh yes, plus 2 tan x plus c. Yes, it is making sense. Okay. First of all, what we need to do is we need to take 2x is equals to t, so that x dx is equals to dt upon 2. Okay. So e power 2x, e power t. Okay, x, oops, x dx, no. dx is equals to, right? Sorry, there is no x, no? Dx is equals to dt by 2. So this is your dx. dt by 2. So dt by 2. This is your dt. Now what about this? Sec square x. So sec square t by 2. And this is 2 tan t by 2. Yes or no? Yes or no? Okay. Now understand, if at all this is my function f of t. What is the differentiation? Ma'am, differentiation tan theta differentiation is sec square theta. So 2 tan t by 2 differentiation will be what? Ma'am, 2 sec square t by 2 upon half. Sorry, into half, 2 to cancel. So this whole thing will be f dash t. Yes or no? So now the integration is actually e power t by 4 into f of t into 2 tan t by 2 plus c. 2 ones are 2 twos are. So now just put the values, e power 2x tan x upon 2 plus c. E power 2x tan x, option C. Okay. Do you want me to repeat it one more time? I can do that. Okay. First of all, I realized that this needs to be solved first thing. So 1 plus sin 2x is sin x plus cos x whole square. Okay. 1 plus cos 2x, gold, 2 cos square x. This half can come in front and this whole square can be taken in complete sense. Sin by cos is tan, cos by cos is 1. Now let's expand it. 1 plus tan x whole square. A square plus b square plus 2ab. 1 plus tan square can be written down as sec square. Now the problem here is that this is in 2x and this is in x. My formula is always in e power t is already outside. So let's do one thing now. Let's put 2x is equals to t so that dx is dt by 2. Let's convert it into t. So it is e power t upon 2 was already there, but 1 by 2 is already there. Not dx will be dt by 2. So dt by 2, that's why this 4 is there. Now just turn. X is what? T by 2. Sec square t by 2, 2 tan t by 2. Now just understand the same thing. Now we need to work on that integral. E power thing is already there. One should be function, other should be its differentiation, which is already there. You differentiate, you will get this. Everything is adjusted now. So your answer will be e power t by 4, 2 tan t by 2. Just convert everything in terms of x, you will get your answer. Okay? Clear? Clear, clear, clear. Do we need to solve another question? JEE main question, by the way. JEE main question. 1 plus x minus 1 by x. Okay. E power x plus 1 by x. Okay, sorry, but before that, okay. Not right now. See, one more question. Just tell me the differentiation of. Tell me the differentiation of x, f of x. Tell me the differentiation of this. Derivative of this. So, ma'am, differentiation will be x, f dash x plus f of x. Acha. So, then tell me the integration of this x, f dash x plus f of x. Will be what? Ma'am, x, f x. So, basically, now you have to identify what? That e power x was slightly visible. Because the moment you see e power x, you might think that, okay, maybe it is from the 2 classic integral. Okay, so this is the second one of 2 classic integrals, second formula of 2 classic integral. Okay, and identification of this is slightly difficult. So you have to hit and trial. You have to think, acha, this question is not working with substitution, not with partial fraction, not with this, not with that. Maybe it is the second classic integral. No formula is applicable. Okay, so now let's do one question. 1 plus x minus 1 by x e power x plus 1 by x dx. Okay, now very first thing would be that let's put x plus 1 by x is equals to t. Okay, or if not, okay, let's do one thing. Let's multiply this. So, e power x plus 1 by x. Can you see I have multiplied it over here? Plus x minus 1 by x e power x plus 1 by x. Okay. Alright. Now, can you differentiate this x plus 1 by x? Now, if you differentiate this, you are going to get 1 minus 1 upon x square. 1 minus 1 upon x square. Okay. Acha, can I take x common from this? See, if you differentiate, na, x plus 1 by x derivative, keep in mind, ma'am, 1 minus 1 by x square. I need to create this. If I take x common, what will I get, ma'am? 1 minus 1 by x whole square. Okay, that means you got it. Yes, absolutely. Okay, so now understand. This is your f of x. Now, if you want to differentiate this, f of x, what will you do? So, ma'am, easy, e power x derivative will be what? E power x multiply using chain rule. So, this whole thing, see, x plus 1 by x, if you differentiate, you will get this. So, this is your f dash x. And your x is also there. Can you see that fx plus x f dash x is getting created? Fx plus x f dash x is getting created. Whose integration you are interested in, right? So, integration of this will be what? X into f of x. Yes or no? Slightly difficult. Have a look. I'll give you a solution one more time also. See, this is how it is. This was it, 1 and x minus 1 by x. So, you multiplied it. This is 1. Now, what we did is we just took x common from this, x and this. Now, clearly this is f of x and this is x. This is completely f dash x. So, fx plus x f dash x you have to create. Once it is identified, then 99% of your problem is solved. You just have to apply the direct formula. Okay? Yes? Chalo. Next question. called e power ln. We know this, right? This is actually, if you modify, na, this is x and this is sin x minus cos x. Not a very difficult question. Okay, can you see if your minus cos x is a function, minus cos x is a function, plus x times derivative of minus cos x is what? Derivative of minus cos x is minus minus sin x plus sin x dx. So can you see this is your fx, this is your x, this is your f dash x. So integration will be what? X fx. So minus x cos x plus c minus x So I think this is wrong. This is correct now because this is minus x cos x. This is more appropriate. So option C is absolutely right. Okay? Yes? Chalo. Next question. Next question ready now. This question, I want all of you to do this question. See, if we can put ln x is equals to t, will it help? X will be e power t. So dx is equals to e power t dt. Now let's convert. Integration of dx will be what? E power t dt. Okay. Now ln t plus 1 upon ln t square. Okay. Sorry, not this. This is actually 1 by t square. Correct? Yes, some noise is coming. Still coming, kya? Let me add some noise cancellation. Is it better? I have activated noise cancellation also. Now I think I need to add something. Okay. Yes. So e power t ln t plus, let's add the derivative of it. Ln t. So if I differentiate, it will become 1 by t. I have added 1 by t and I will subtract 1 by t plus 1 by t square. Now it will make more sense because two things are getting created. Understand? See, this is what? E power t. This is your fx. Fx. And this is your f dash x. Remember? Two classic integral first formula. So e power t fx plus f dash x. So this much part is sorted. The answer would be what? E power, sorry, this is t. Answer would be e power t into f of t. So this part is done. E power t and ln t. Correct? Now minus sign if I take common. So this is 1 by t and minus 1 by t square. If you take minus 1 by t common, this is your g of t and this is your g dash t. Minus sign common, 1 by t derivative is what? Minus 1 by t square. Or you take minus 1 by t only. Gt is minus 1 by t, derivative is this. So now again e power t is already there. So, this is going to be minus e power t and this is upon t plus c. Basically, simultaneously two formulas are getting created. Two same formulas. Now just e power t. What is e power t? X. What is ln t? So ln of ln x minus 1 by t square is fx. Why? Why, Gokul? See, derivative of this is this, na? Now, e power t is x, t is ln x plus c. Let's see. X, ln x minus x. Can you see option D is absolutely cool over here? Very good question. Very good question. Yes, everybody? Getting it? Okie dokie. Now, slightly difficult part, but not difficult. It's a formula based. So remembering formula is slightly headache for us, right? But don't worry, I'll make it easy for you. Square root a square minus x square. Remember, 1 upon square root a square minus x square was related to sine inverse x by a, but it was in denominator. Now it is in numerator. So again, sine inverse x will come into the picture, but it is going to be 1 by 2 x copy paste, half x copy paste plus half a square, and you know what, your very own sine inverse x by a. Just remember this formula. Okay, how to solve it? A square minus x square, just put x is equals to a sine theta and dx will be a cos theta d theta, and convert this. So this is going to be a square minus x square. So this is going to be 1 minus sine square, which is cos, and one more cos from the dx. So this is how it is. Cos square theta integration will be done by gold formula, 1 plus cos 2 theta by 2. Okay, and this is how it is going to be. and you just have to now integrate it. After integration, put the values, you will get it. Okay, but that's how you need to remember. Square root a square minus x square half x. Copy paste half a square sin inverse x by a. Okay, similar formula over here. Remember, we saw that formula 1 upon square root x square plus a square. It was in denominator in the root. So the answer was log of mod of x plus copy paste. We just did it. Okay, now this is in numerator. Whenever it goes in numerator now, then the formula will be slightly difficult. Okay, so it is going to be half x, copy paste. Again, half x, copy paste, plus half a square, the previous old formula. That's how you need to remember it. Okay, same here also now. Half x, copy paste, half a square, previous old formula. Let's do. So this is how this is how it is. And same, square root x square minus x square is also half x, copy paste. Now this time minus sign. Half a square log of x plus square root x square minus a square. Can you see this? Now let's solve this question. Square root x square plus a square, bam. Okay. Half x, copy paste, plus half a square. So this is a square. And you know what? Previous old formula, which is log of x plus copy paste. That's it. See, understand the pattern, you will be done. So this will be your answer. Okay. Next question. Done. Next question, 3 minus ln x. Again, in this question, it is pretty obvious. First, we have to put ln x is equals to t, so that 1 by x dx will become dt. Integration of square root of 3 minus t square upon is not there. No, 1 by x dx is gone. It has become dt now. So square root a square minus x square. What's the formula? Square root a square minus x square. The formula is that sin inverse. Okay. So 1 by 2 t by 2 basically. And then we have copy paste. Plus 1 by 2 a square. And same old sin inverse. Now put the value of t. So ln x by 2 square root 3 minus ln square x plus 3 by 2 sin inverse ln x by root 3 plus c. Yes? Okay. Is it difficult? It is not difficult. See? Okay, now 3 special type of integration. Now let's understand that, see, now this part of integration, whatever we are starting now, this will tell you about that if you get this, do this. If you get this, do this. So you just need to remember the format. Okay, so integration, indefinite integration, some people feel that very difficult. But you know what? It is not very difficult. It's just that there are so many things to cover. If you talk about difficulty level would be that you have a question and you're not able to think about the answer. Indefinite integration might look difficult to you only because you don't know the formats. Okay, it can be mastered. If you give time, indefinite integration will reward you. But there are some chapters, even if you give time, syllabus is also very small, but thoughtful. It is so thoughtful. Suppose probability, permutation and combination. Then complex number also. Okay, so these are the difficult ones in terms of thinking. Indefinite integration is testing you on a lot of things, memory also. So if you are doing hard work, indefinite integration will reward you. But in probability, PNC, even if you do hard work, you keep on doing hard work, it will not reward you like that. For that, real intelligence, real brain will be required. So this is not a very heavy chapter, but not difficult. Okay. Whenever you see 1 upon quadratic, 1 upon root quadratic or root quadratic, three things. Same medicine. Three type of integration, same medicine. 1 by quadratic, 1 by root quadratic. Just make perfect square. I hope that you know how to make perfect square. For example, this root quadratic. Make perfect square. So x square, please add 1 and subtract 1. So this is x plus 1 whole square minus 2 square. So this will be treated same as square root of x square minus a square. It will be what? X by 2. Okay. Then copy paste. Or rather write the direct one. No, eventually you will solve it only. So x square plus 2x minus 3. Okay, minus 1 by 2. This had a minus sign. Minus 1 by 2 a square. And the previous same old formula, log of mod of x plus copy paste. I'll tell you which formula I'm talking about. So I am talking about this formula. Square root x square minus a square. Now half x copy paste minus half a square. Same old formula. So same, see, I have applied it same. X plus 1, this is x by 2, copy paste. Minus half a square, same old formula. Okay. So your answer will be what? But please understand, this is log of x plus, so this is x plus 1. So can you see this is half x plus 1? Your question, minus 4 by 2 log x plus 1 plus same thing. Yes? Okay. So this is how it is. Now the next question. Integration of x upon x power 4 plus x square plus 1. Okay. So now this time x square will be assigned as t, so that x dx will become dt upon 2. X dx will become dt upon 2. Okay, so integration of x dx, dt upon 2. And this is going to be t square plus t plus 1. And I told you, 1 upon quadratic, whenever you see, what to do? Just make it as a perfect square. So this is dt upon, how to make perfect square? I hope everybody is aware. T square, so this is t plus half whole square minus 1 by 4 plus 1. Okay, so basically you have to take half of the coefficient of t, half of it. So t plus half whole square, and you need to square and you need to subtract the square of half. That's how it is. So this is 1 by 2 dt upon, this is what? T plus 1 by 2 whole square. This is plus 3 by 4, which is root 3 by 2 whole square. Do you remember? This is 1 upon x square plus a square. So 1 by 2 is already there. What's the formula? 1 by a tan inverse x by a. 1 by a tan inverse x by a. So 1 by a, that means 2 by root 3. This is a. 1 by a tan inverse t plus half upon a. Okay. Now you can just change. So it is going to be 1 upon root 3 tan inverse. Okay. And if you multiply 2, this is 2t. So 2x square plus 1 upon root 3. And this is plus c. So 1 by root 3 tan inverse. Can you see option C clearly? Is absolutely right. Yes? Okie dokie? Clear? Format change. So what was the previous format? Quadratic, root quadratic, 1 by root quadratic. Whenever you see that, just convert into perfect square and eventually one or the other formula will fall into the place. Now whenever you see linear by quadratic, linear by root quadratic and linear into root quadratic, can you see the format is same? Previously it was 1 by quadratic, 1 by root quadratic and root quadratic. These were the three things. Now the linear got attached. So linear by quadratic, linear by root quadratic, linear into root quadratic. So your linear should be expressed as constant multiplied derivative of quadratic plus b. I'll show you what I'm trying to say. See, suppose this. Can you see linear upon quadratic? So your 2x plus 1 should be expressed as a times derivative of this main quadratic. So derivative will be what? 2x plus 2 plus b. Okay. So what will happen? Now tell me. So ma'am, clearly 2ax, compare. So a is equals to 1. 2a plus b is 1. So 2 plus b is 1. So b is minus 1. Okay. So 2x plus 1 now will become what? Change. 1 time 2x plus 2. Okay. Minus 1. Okay. Upon this is what? X square plus 2x plus 2. And this is again x square plus 2x plus 2. The first half of the integration. How will you do it? Just put this as t. Put this as t. This is your t. With dx, this will become your dt. So this is what? Log of mod of t. Easy. Minus. What about this part? Now this part was 1 upon quadratic, no? We have learnt it, just perfect square. So this is what? This wala part is 1 upon x plus 1 whole square plus 1. Remember, 1 upon x square plus a square integration tan inverse. So 1 by a. A is anyway 1. Okay, so this is tan inverse x plus 1 by 1 plus c. Tell me, is it difficult? Not very difficult, right? See, so what we did? 2x plus 1, the numerator, the linear part is written down as a times derivative of quadratic plus b. On comparing, you can get the coefficient and now write it as 2x plus 1 will be 2x plus 2 minus 1. So this is I1, this is I2. So this is the very easy. Now if you put t, this will be dt. That's why we did this. And this was the previous category, previous format. Integration number 2 will be what? Like this. So integration of this perfect square and easy peasy. So your final answer is this. Okay. Chalo. Now shall I give you one homework question x plus 1 upon or do you want me to do it right now? Homework or right now? Chalo, let's vote. Homework or right now? Is the sound bothering too much? Is this sound bothering too much? Kya? I don't know because noise cancellation I have activated. I don't know how it is coming across. Homework, so yes, again, x square plus x. Sorry, x plus 1 will be a times 2x plus 1. See the derivative plus b. Now just compare. So clearly A will be half, and this is B is also half. Okay. See, if A is half, B is half. So now half times 2x plus 1, half times this. So now if you put this as t, this will be dt. So this is 1 upon 2 root t. What is the integration of 1 upon 2 root t? It is just root t. So answer will be what? Directly square root x square plus x. And for the second part, you have to make it as perfect square. This is 1 by 2. Now make it as perfect square. So x square plus 1 by 2, x plus 1 by 2 square minus, okay, so this is square root of x square minus a square in the denominator. So it is going to be what? Square root of x square minus a square in the denominator. So this is very simple. This is plus half, and you know what? Log of mod of x plus copy paste. Here x is x plus half plus copy paste. This is how the problem is going to be. I'll show it to you also. See, half log this. See, this is your final answer, right? I told you, no? This and this. Okay? Clear? Chalo. Now, this is something which is really important. Okay? And maybe, let me check one time. Maybe this is our, yes. Not the last. Oh. Okay, no, we have a little to cover. Okay, so this is very important. That's what my whole idea was. Okay, so yes, what is this? Integration of the type x square either plus 1 upon x power 4 plus kx square plus 1 or minus 1. See. Okay, so this is the category of question. Now there are two categories. We'll tackle one by one each category. Okay, so very first category, chalo, let's do it by question only. Okay, so this is the pattern: 1 plus x square whole upon x power 4 plus 3x square plus 1. So basically in the numerator it will be either 1 plus x square or 1 minus x square. In the denominator there will be x power 4 plus 1 plus kx square. Okay, understood the pattern? Now whenever there is 1 plus x square, you have to put x minus 1 by x is equals to t. When depends on the numerator. If numerator is 1 plus x square, put x minus 1 by x is equals to t and divide the whole numerator and denominator by just x square. X square come out. Okay. Now put x minus 1 by x is equals to t. Differentiate. So ma'am, it will be 1 plus 1 upon x square dx is equals to dt. Now do you know, if there is a plus, why did I actually put minus as t? Because upon differentiating, this sign will become plus, and this is what you're going to get. Okay, this is how we do substitution. Substitution is based on, eventually we need to vanish the numerator or vanish the thing which is in product with dx. Okay, so this is dt. Now what about x square plus 1 by x square, ma'am? So x square plus 1 by x square is actually x plus 1 by x whole square. But you know what? If you're going to open it, a square plus b square, it is going to be plus 2ab. So you need to subtract also. So x square plus 1 by x square will become what? X plus 1 by x whole square minus 2 plus 3 will be plus 1. Okay, and this is nothing but what? This is your t only, no? Oops, no. Wrong. Because see, how can I put t? Sorry, wrong. I need to write it in terms of x minus 1 by x. Now tell me. So ma'am, if now I open it, it will be x square plus 1 by x square minus 2 will be there if you open it. So to compensate, you have to add plus 2. Okay, so now it's clear. It is going to be what? X minus 1 by x whole square, and it is plus 2 plus 3. So plus 5. And this is anyway t. So it is dt upon t square plus root 5 square. Now do you remember which formula is this? Tan inverse t upon root 5. Right or wrong? 1 upon a, please do not forget, plus c. Now you can just convert, this is 1 by root 5, tan inverse x minus 1 by x by root 5 plus c. Yes? See, this is the answer. Any issue, any problem? Are you getting it? Okay, so whenever you see 1 plus x square, put minus as t. But now when you see 1 minus x square, put x plus 1 by x is equals to t. So it is going to be what? 1 minus 1 by x square dx is going to be dt. And also if you square it also, no? It is x square plus 1 by x square plus 2 is equals to t square. Square it both the sides and put. Now what you need to do is take first of all x square common or divide by x square. So 1 by x square minus 1 whole upon x square minus 1 plus 1 by x square dx. Now this is what? Minus dt upon x square plus 1 by x square is t square minus 2. So t square minus 2 minus 1. Now do you remember this? dt upon, this is what? 3 minus t square. Remember a square minus x square wala thing. So this is root 3 square. So 1 upon 2a log of mod of a plus x. So root 3 plus t and root 3 minus t plus c. Okay? All right? Clear? So this is how it is. But it had a negative sign. We don't have a negative sign. That's why answer will be slightly different. Okay? Eventually, we need to anyway absorb the negative sign. Now, again, this type. Now, ma'am, what is this? You were teaching something else. Now, this is something else. What is this? So, integration of the right type root tan x. Integration of the type root tan x or root cot x also. Or root cos x. Cot x. Both are actually lying under the category which we have just studied. Okay, which is what? So just put tan x is equals to t square. So tan x is equals to t square, correct? So tan x. Now sec square x is equals to 2t dt dx. Okay, now you'll be like, ma'am, hold on. Yes. So dx will be what? 2t dt upon sec square x. Sec square x. Can I write sec square x as 1 plus tan square x? 1 plus t power 4. So now convert. Integration of root tan x. So root t square is t. Okay, ma'am, clear. Now what? Now your root tan x is t. Now your dx. Dx will be what? 2t dt upon 1 plus t power 4. So ma'am, what did you get? 2t square dt upon 1 plus t power 4. Okay, now what you need to do is, you need to just add and subtract 1. See. 2t square. Now you'll be like, ma'am, but still we didn't get that form. I'll show you. Whenever you see t square upon this t power 4 plus something, see, t square is there. See, denominator is there. Denominator is correct, but numerator is not there, ma'am. Because numerator either should be x square plus 1 or x square minus 1, like that. So we'll create both. Now this is t square plus 1 plus t square minus 1. And this is t power 4 plus 1, t power 4 plus 1. Integrate with respect to dt. Now what? How to differentiate, ma'am? Both. Yes, both. Plus or minus together. So this is a different, this is a different. Now take, so this is 1 plus 1 upon t square. This is t square plus 1 by t square. Integration. Plus, what about this? Take common, so 1 minus t square plus 1 upon t square dt. So now just understand. In here you put a minus 1 by a is equals to t. Sorry, t minus 1 by t is equals to a. T minus 1 by t is equals to a. And this is t minus t plus 1 by t is equals to b. Right or wrong? So this, if you differentiate, you will get dA. I1 will be what? dA upon. Now this t square plus 1 by t square. So this is minus 2. A square plus 2. It is going to be what? 1 by a tan inverse a by root 2. What about I2? I2 will be again dB upon. If you square it, t square plus 1 by t square plus 2. So it is b square minus 2. So this is b square minus 2. So this is nothing but 1 upon 2 root 2. Remember, log. 1 upon x square minus a square. So 1 upon 2 root 2 log of. This is what? X square minus a square. So it is going to give you, if you take minus sign out, so a plus x, 2 plus b. So 2 plus b will be here, and root 2 plus b and root 2 minus b. And you know what? Eventually you have to turn this into t, then x. Okay, so I'll show you also. See, this is your first integration. This is your second integration. What we did was, over here, t minus 1 by t will be p. So this is, so we have calculated only. And that second integration, let me tell you, this is the first only, right? And now in the second integration, t plus 1 by t is z. So that's how it is. So this so we have done already. And it will be log. This is your log. Eventually the final answer will be what? This is your I1, this is your I2. Now t eventually will be replaced by root tan x. A little bit lengthy, but so this is for you. I am leaving this for you. Indefinite integration. You should understand the process, but at least. Okay? All right. Clear? Chalo. Now what we will do is we'll continue. See, we'll keep it till here only because I know things are getting heavy in integration. So now I think what is pending, let me tell you that this kind of integration, linear, root linear, quadratic, root linear, that many of you can do it. One question. Start solving it, okay? So again, whenever you see square root of linear quantity, so 2x minus 1 will be what? T square. 2 dx is equals to 2t dt. Okay? Right? So now let's just convert this. So x plus 1. See, x over here will be t square plus 1 by 2. X plus 1 whole upon. This is what? Just t. Integration. Now dt will be replaced, dx will be replaced by 2 to cancel, right? So dx will be replaced by t dt. T also cancel, right? So what you're going to get is t square plus 3 upon 2 integration dt. Not a very difficult. Huh? T square 1 by 2 will remain outside. T square t cube by 3 plus 3t plus c. Now 1 by 2. Or what you can do is actually take t common. Take t common. So if you take t common, it will be t, and this will be t square by 6 plus 3 by 2t plus c. Now put the value of t. So ma'am, t is what? Square root 2x minus 1 will remain outside. That, why did I do that? Because I want this to be separate. Now the but whatever is rest is your f of x. F of x, t square by 6. So 2x minus 1 upon 6 plus 3 by 2, and then we have into t, which is square root of 2x minus 1. Am I doing anything wrong? X plus 1. That's correct. T square plus 3 by 2. है ना? T square 3t. Am I doing anything wrong? See, this is what we have got correct. Now this is correct. T, T have, okay, oops. T I have already taken common now. So if you take common, T will not be there. So this will not be there. That's it. So this is what your fx looks like. This is your f of x. Now solve it. 2x minus 1 plus 6 by, hold on, this is plus 9, right? Into 3 by 3 plus 9 by 3 to the 6. 2x plus 8 by 6. X plus 4 by 3. X plus 4 by 3, option D. Okay, done. X plus 4 by 3. This is your fx. JEE Main 2019 question you have done. All right. Yes. So whenever you, now you know, whenever you see square root is there and square root of linear, so basically just put as t square. Not very difficult stuff. Okay. Now this time you have square root of quadratic. See, whenever you see square root of quadratic, I told you, if it is just square root of quadratic, then you have to make it perfect square. But If at all square root of quadratic is having a friend, linear or quadratic, it could be anything. Understand? Linear root quadratic or quadratic root quadratic. Understand? 1 upon linear root quadratic or 1 upon quadratic root quadratic. Then what you have to do is put linear is equals to 1 by t. Okay. So whenever linear root quadratic is there, you have to put what? Linear is equals to 1 by t. And whenever quadratic root quadratic is there, you have to put just x is equals to 1 by t. Okay. Chalo. Let's see. We'll solve some problems, then only we'll be understanding. Okay. Now, ma'am, this is linear root quadratic, the first pattern. So, ma'am, put linear is equals to 1 by t. Now you'll be like, if you are able to remember this only, na, things will automatically fall in place. Just convert it into t, automatically you will understand. Just remember this, that's it. So x plus 1 is equals to 1 by t. So 1 by x plus 1 will be t. Okay, now differentiate this. So ma'am, dx is equals to minus 1 by t square dt. So dx will be what? Minus 1 by minus dt by t square basically. What about this? 1 upon square root of, see, this x plus 1 will become 1 by t, that's so it's there. What about x square? X square will be what? Ma'am, x square will be first of all 1 by t minus 1 whole square. Okay, this is how it is going to be. So this t and t square. So this is integration minus dt whole upon. Okay, t is already outside. Now let's see. 1 upon t square plus 1 minus 2t. So sorry, minus 2 by t. Plus 1 by t was already there. You just have to solve it. Don't worry about how to actually integrate. Just keep on solving. Take LCM also. So dt upon t is already there, square root. Now this is t will be t square. Okay. Oops, no. T will come out and it will get cancelled. Understand, this t is over here. Looks like it is not there, but understand. Where is t? So t is here. And 1 by t will come out. Now if you take LCM, what will happen? This is actually 1 by t, right? So it is 1 plus t square plus t. This is how it is. Now what to do? So this is dx is what? Minus 1 by t square. That's correct. 1 by t will be there. And x plus 1 is equals to 1 by t. So 1 by t minus 1 whole square. T will come out. This t is gone. No, oops. This t is cancelled out. Yes. So now can you see this question is purely square root of 1 upon square root of quadratic. What to do? I'll wait a minute. I want you all of you to answer it. Now what to do? I just told you now that just follow the instructions, keep on solving. What are you going to get? Is something which you already know. This is an integrable thing. Remember I told you, whenever you see 1 by root quadratic, make perfect square. That's it. So this is what? Square root of, make perfect square. T plus 1 by 2 whole square minus 1 by 4 plus 1. So this is plus root 3 by 2 whole square. Do you remember this? 1 upon root x square plus a square is nothing but log of mod of x, t plus half. Plus copy paste. What is copy paste? Square root of t square plus t plus 1 plus c. Now just convert. T, put t is equals to what? 1 upon x plus 1 and you will be done. Okay, so I'll show you one more time what we have done over here. The very first thing was put x plus 1. Linear is equals to 1 by t. So first of all, you have to identify the format and put the values. You don't know what's going to happen. Just trust the process. Trust the process. Sometimes you feel, ma'am, I don't even know what will happen to this expression. Even I don't know. I just know one thing. If I am going to put x plus 1 is equals to 1 by t, and if I do clear-cut right calculations, okay, what will happen is I will get something which is a format which is integrable. I just forgot a negative sign. Okay, let's put a negative sign. Okay. So this is what it is. T square minus t was there. Kya? Sorry. I wrote plus t, no? So it was minus t. Oops. It is minus t. T square minus t. So this is minus half. So it is minus half and this is minus. Okay. Anyway, I am telling you, no, where it is. So yes, this is square root of x square. Remember this formula we have studied. Same formula you have to. This is your x. This is your a. Okay, a square basically. So this is how it is, and you just solve it. You're going to get this. Clear kya? Clear? So now understand the pattern. I will revise everything. Don't worry about it. For example, this question. I want all of you to try this one. 1 upon quadratic into root quadratic. Oops. Ma'am, whenever this type of pattern will get, we know what to substitute. We just need to put x is equals to 1 by t. So dx is equals to what? Minus 1 by t square dt. Now keep solving it. Start solving it. So ma'am, to solve it, integration of 1 upon x square plus 1. So this is 1 upon t square plus 1. And you know what? This is square root of 1 upon t square plus 2. Dx, don't forget to change dx. So dx will be what? Minus of 1 upon t square dt. Keep solving it now. So ma'am, okay. If you keep solving it, this is minus dt upon t square whole upon this. T square plus 1 upon t square. And if you solve this, this is going to be square root of 2t square plus 1 upon t. Yes or no? Yes or no? T square cancelled out. It will go up. So this is going to be minus dt and t is already there. This t will go up upon t square plus 1 square root 2t square plus 1. Okay, this is what you're getting. Now think about that how to integrate this individual thing. Now forget about the overall question. Think about this. So ma'am, I feel that if you put t square is equals to something. Okay, now it depends upon what you're getting. So t square suppose is equals to a. So 2t dt will be dA. So t dt will be what? Minus dA upon this is a plus 1 and this is going to be what? Square root of or rather you can put t square is equals to a square only. Not t square. Actually, you have to put this is equals to. The better approach would be what? That square root should go off. Square root should go off. Now, so 2t square plus 1 is equals to a square. That is much better. So this is 4t dt is equals to 2a dA. So this is what? 2. So t dt will be what? T dt will be what? A dA minus upon 2 and this is what? This is going to be a square, so a. Okay, what about this? T square plus 1 is left out. So t square, a square minus 1 by 2. This is what? A square minus 1 upon 2 plus 1. A cancel, integration is already there. So minus dA upon 1 by 2. Okay, and this is what? A square, this is what? Plus 2 minus 1. So plus 1. And there is a 2 also. So this will be 2. This is also gone. Oops. This is so simple now. Tan inverse A, tan inverse A plus C minus tan inverse A plus C. Okay, so let me see, this is the solution. Okay, so this is the solution, right? So over here, now understand that what we have done is, this is x is equals to 1 by t, right? So whenever you see quadratic root quadratic, what will you do? Put x is equals to 1 by t and keep on solving. Trust the process. Eventually, whatever you are going to get is nothing but an integrable form which you have studied. Like, it would be either by parts or it would be either some mostly it is substitution. Mostly it will be substitution. Okay? All right? Yes? Okay. Let's talk about partial fraction now. Okay? Ready for partial fraction? Tell me. Ready for partial fraction? So in partial fraction, what happens is that first of all, you will get a rational expression like this. Can you see this is a rational expression? Okay. So rational expression may sometimes what will happen? The degree of numerator. Now understand, the degree of numerator should be less than degree of denominator. If not, then what to do, that we will see later. But right now, understand. To apply partial fraction, basically, why are we applying partial fraction? So this expression right now is non-integrable, but we have to like change the format. We have to simplify it, and then eventually it will become integrable. Understand this. So over here, this is what degree of numerator is 1, degree of denominator is 2. So yes, now this is a safe format. We can use partial fraction over here. What we are going to do is, we are going to first of all split or factorize the denominator. Factorize the denominator. The moment you factorize the denominator, what will happen? X minus 2, x minus 3. Now, when you see that this is happening, now just quickly write it as separate. You know, we separate, we take LCM, that means combining. What we do is reverse process. See, suppose 1 by 2 plus 1 by 3 is there. So it is very easy. 3 to the 6, ma'am. 3 plus 2, 5. But if I am going to give you 5 by 6, then how are you going to write it as 1 by 2 plus 1 by 3? That is something which is slightly difficult, right? Combining is easy. Solving is easy. Unsolving, this is something unsolving. Partial fraction is can also be called as unsolving. So that might take a little longer. So this is a upon x minus 2 plus b upon x minus 3. Okay, this is the format. A and b, you have to figure it out. Okay, how to figure out a and b, we will see. Let's see right here. First of all, just write it as this. Okay, now what we need to do is, we just need to compare. So take LCM on the right hand side. So ma'am, a x minus 3 plus b x minus 2. Okay, so this is x minus 2, x minus 3, and this is what? X minus 1 upon x minus 2, x minus 3. Now obviously, what you need to do is you just need to compare. So one method would be the longer method, the CBSE method, the NCRT method. That ma'am, the coefficient of x is 1 on the left hand side and the coefficient of x will be what? A plus b. The coefficient of the constant term is minus 1 on the left hand side and this is minus 3a minus 2b. Now just solve for a and b. But this is not something which we are going to do. What we are going to do is use the shortcut method, shortcut technique. Shortcut says that just put, this is your equation, put x is equals to 3 and put x is equals to 2. So put x is equals to 3. So the moment you put x is equals to 3 in this equation, 3 minus 1 will be 2 is equals to, this is 0 and this is what? B into 1. So directly in one step you will get the value of b. And now put x is equals to 2. The moment you put x is equals to 2, this will be gone. Okay. So it will be what? Minus a is equals to, minus a is equal to 1. So a is nothing but minus 1. A is minus 1. Okay. A is minus 1 and b is 2. A is minus 1 and b is 2. Now the moment you have your a and b, minus 1 and 2. So just write. Can you see? Just write. This will be minus 1 upon this. B is 2. Now can you see this is integrable? This is integrable. So this is minus of log of x minus 2 plus 2 times log of x minus 3 plus c. That's it. Done, done, done. This is how you need to integrate. Now understand that you have to learn the format. I told you, this was just a glimpse of partial fraction. Now you have to remember that if at all you are going to get this, you have to write like this. If at all the expression is of the type this, you have to write like this. Now see, when the denominator is having product of non-repeated linear factors, just like this, x minus 2, x minus 3 was in denominator, right? What does that mean? That means the denominator is having linear but non-repeated factors. Nobody is repeated. X minus 2 is written once, x minus 3 is also written once. Okay, so non-repeated linear factors are there. I don't know, I don't care how many linear factors, but non-repeated linear factors. Okay, so it is going to, you can just separate, just write constant upon first factor, constant upon second factor, another constant, and so on. This is the format you need to write. Okay, now I want all of you to try this question, and this was a JEE Main PYQ. Try this. This is based on partial fraction, but before, like, this is like just one step. You just have to substitute something and then eventually you will get what the partial fraction basic looks like. Okay, so I'll give you some time to solve it so that you understand what I'm trying to say. What will you do? Put sine theta is equals to t. So cos theta d theta will become dt. And you know what? This will be integration of dt whole upon 5 plus 7t minus 2. Cos square theta will be what? Cos square theta will be 1 minus sine square theta. So 1 minus t square dt upon 2t square plus 7t. 5 minus t is what? 3. Okay. 3 2s are 6. So now what you can do is dt upon 2t square plus 6t plus t plus 3 dt upon 2 times t plus, okay, 2t plus 1, 2t plus 1 and then t plus 3, correct or not? So now this can be written down as, I'll take one more slide. So 1 upon 2t plus 1 and t plus 3 can be written down as a upon 2t plus 1 plus b upon t plus 3. Okay. Now 1 will be equals to a times t plus 3 plus b times 2t plus 3. Correct. Put t is equals to minus 3. Put t is equals to minus 3. So 1 is equals to 3 minus 6. So minus 3b. 3 minus 6, correct? So b is equals to minus 1 by 3. And same, now put t is equals to minus half. Are you understanding on what basis I am putting t? I am putting this, that this expression will become 0 at what value of t? This expression becomes 0 at what value of t? T is equals to minus half. So this time, sorry, this is 1, right? So this time this will be 0. And if you put minus half, 3 minus half times a is equals to 1. So this is a will be 2 by 5. A will be 2 by 5, b is minus 1 by 3. So this is 2 by 5 upon back, what is a? 2 by 5, the 2t plus 1 minus 1 by 3 upon t plus 3 integrate with respect to dt. Okay, so this is 2 by 5 log of mod of 2t plus 1. Please do not forget one thing. Please do not forget one thing. That 2 will be divided over here. So this is 2 by 5 is already there now. 2 will be divided. Why 2? Because this will be differentiated in the denominator. Remember I told you in the very beginning. Integration of f of ax plus b. So a will be divided in the end. Minus 1 by 3 log of t plus 3 plus c. Okay, so 2 cancel. So this is what? 1 by 5. 1 by 5 log of mod of 2t plus 1 minus 1 by 3. I hope I am doing correct. This is minus 1 by 5, not minus 1 by 3. Hold on. If you put t is equals to minus 3, so here if you put minus 3, it will be what? Sorry, this is 1 now. That's why. So this is 5. This is 5. This is 5. Oops. So b is minus 1 by 5. Okay. This is 1 by 5. Okay. So this is also 1 by 5. Minus, so better if it is 1 by 5 log of mod of t plus 3. Okay. Now 1 by 5 if you take common, what will happen? Log of mod of 2t plus 1 upon t plus 3 and this is plus c. So 1 by 5 log of b theta. So a, what is a? A is 1 by 5. See, what they are asking is b upon a. What is b? This is your b and this is your a. B by a. So b by a will be what? 5 times 2 sine theta plus 1 upon sine theta plus 3. This is your answer. So this is matching with option D. Have a look. Let me know. Clear है क्या? Is it clear? Okay. Now understand. So you might be thinking that, ma'am, okay, when degree of numerator is less and degree of denominator is more, so then so you told us what to do. But what will we do when the degree of fx is greater than degree of gx? Then you just do that proper division, polynomial division, remember? Whenever, see, even if they are equal, now quadratic by quadratic, just divide. If you are going to divide, now what will happen eventually? You will get something where the degree of numerator will become less. For example, let's take this. Okay, numerator degree is more, denominator degree is less. So right now you can't apply partial fraction, but what you can do is just divide. X square minus 5x plus 6. This is x cube minus 4x square plus 2x plus 5. Okay. Now x square, so x. So multiply x into this, x cube minus 5x square plus 6x. Subtract. So this is gone. This is nothing but what? X square. This is nothing but minus 4x plus 5 is already there. Now what to do? Plus 1. Multiply x square minus 5x plus 6. Subtract. Gone. This is x. This is minus 1. So now your answer will be what? X plus 1. Okay. Plus x minus 1 upon x square minus 5x plus 6. Quotient plus remainder by divisor. Correct or not? So see, this is what you're going to get. Now integrate this. This is very easy. This integration is x square by 2 plus x. What about this? Again, this will be done as partial fraction. In fact, this though we have just done. Remember, the very first question was of partial fraction was this only. So a and b minus 1, 2 we have got, and this will be what we have got. Now just integrate. So this is what? This. And eventually just integrate. So this is x square by 2 plus x minus log of x minus 2 plus 2x minus 3. So this is what your answer will look like. Clear? Everybody getting it? Yes? Partial fraction. So case number 1. Understood kya? So till now what we have understood is whenever you get the degree of numerator more and degree of denominator less, just divide. Divide, polynomial division basic. Now, once you divide, then it will fall under either case number 1, where there are no repeated linear factors like this. Can you see that here there are no repeated factors, x minus 2, x minus 3 ones, okay? But now case 2. Now denominator is having repeated factors, just like this. Can you see? X minus 1 whole square. So there is one factor which is repeated. Other two are non-repeated, but one factor it is repeated. So what to do now? In that case, what you have to do is x minus whole square now. So it is a upon x minus 1 plus b upon x minus 1 whole square. This is how you have to tackle this repeated root. Now what about next, ma'am? X plus 1, x plus 2, it will remain same. Just one write xc upon this and d upon x plus 2. Once you are done with that, take LCM and the same procedure will be there. Okay. So let's do one question based on this. Let's see how many of you can do it. So this is your question. I'll give you some time. Solve it. Let me know. Are you doing it? Yes. So this integration, so we'll talk about it a little later. See, this is 1 upon x plus 1 whole square is equals to a upon x plus 1 plus b upon x plus 1 whole square plus c upon x. Correct? This is how you need to apply partial fraction technique. Now just take LCM on the right hand side. So it is a, see, x plus 1 is already there. So if you take LCM, x plus 1 into x plus bx plus c times x plus 1 whole square. That's how you take LCM, right? X plus 1 was already there. So what is not there? Ma'am, x and x plus 1. X plus 1 whole square is already there. So what is not there? Just x. X is already there. So what's not there? X plus 1 whole square. Now put something. Put x is equals to 0. So what will you get? 1 is equals to, this is 0, this is 0, and this is 1 is equals to c. C you have got. Now put x is equals to minus 1. So it is 1 is equals to, this is gone, minus b. So b is nothing but minus 1. Now put anything you want. Put x is equals to 1. what will happen? 1 is equals to 2a plus b plus 4c, correct? 1 plus 1, 2, 2 square, 4c. So 2a, 1 is equals to 2a. So this is minus 1 plus 4. So it is plus 3 and it will go on the left hand side. So this will give you 1 minus 3, minus 2. A is coming out as minus 1. Okay. A is coming out as minus 1. So now this is what? Minus 1 upon x plus 1. So minus 1 ln mod x plus 1 if you're going to integrate it. I am directly integrating and substituting value also. Now Gokul is writing Samjha ma'am. Gokul, you know Hindi also. What about this integration of this will be minus b. So minus b. So it will be 1 upon x plus 1. Right? Integration of this will be what? Minus 1 upon x plus 1. Then this is plus c. C, where is c? C. So c log of mod of x. C is anyway 1, right? Plus c. So now you have to like combine these two as per the question. So 1 upon x plus 1 plus log of mod of x upon mod of x plus 1 plus c. This is what you're getting. 1 upon x plus 1. So 1. A is 1 and B is also 1. Option C. A is 1 and B is also 1. Right? So option C. Yes. Getting it? Okie dokie. Ma'am, I'm getting 0, 1 and minus 1 as the answer. What is 0? Huh? Only A and B they are asking. What happened? Chalo, you note this so that we can proceed. Now another type is coming. Integration of some trigonometric related functions will be there. Gokul, just give me a big thumbs up if you have understood it. Okay. Chalo. Now this type of question. Thoda only, Gokul. Clear, Mohammad Ashraf? Okay. Now integration of trigonometric functions. It is not visible right now, but it is integration of trigonometric functions. So whenever you see 1 upon sine square, 1 upon cos square, or 1 upon combination of sine square, cos x or sin x cos x, basically in the denominator, the denominator either it should be sine square or cos square or sin x cos x, or combination of all three will also work. Basically the degree of that trigonometry should be 2. See, this is 2, this is 2 and this is also 2 now. 1 sine, 1 cos. Either 2 cos, either 2 sine or 1 sine, 1 cos, like that. So if you get this now, then you put tan x is equals to t, that's it. Put tan x is equals to t. So automatically you have to have sec square dx in the numerator. So you have to create that. But ma'am, able to read and write Hindi fluently. Kya baat hai? Very nice. Chalo. But you see, I think, see, I'm very bad at languages, but I feel that learning languages faster is something which not many people can do that. And in fact, as you age, I don't know what happens, why it happens. As you age, you have less tendency to learn new languages. So that's why when you are young, when you are below 30, below 25, so much better. Just try to learn as much as languages as possible. Okay. I mean, I don't want you to like burden, but yes, if you want to learn something, now think about what should I learn. Not right now, after JEE obviously, but in college also, you can think about learning Sanskrit also. You can think about learning German also. I think Sanskrit, one language and one foreign language apart from English. Like English, though, I know it's a survival thing. English, though, everybody should understand. Otherwise, how will you talk to like international people? So I feel Sanskrit, okay. I actually started a course. I joined a course. I couldn't do it, and but yes, I was like, I want to learn Sanskrit and German, Spanish, I don't know. I mean, it's a good to have, good to flaunt also, no? Sometimes you just say your introduction in some random language. People will shock. People will be like, what the hell? Okay, Mohammed is saying 3 languages. Mohammed, what all language? Chalo, this question. Whenever you see 1 upon sine square, put tan x is equals to t. But you will be like, ma'am, from where are you thinking tan x is equals to t? Because this question, look at the face of this question. How can you think that tan x will be t? But yes, see, this is why integration is all about learning formats also. So now if you tan x is equals to, you know, sec square x dx is equals to dt. What does that mean? You have to multiply sec square x in numerator, sec square x in denominator. So this is going to be what? Dt upon, now understand, this is sine upon, see, if you multiply this sec square x now, what will happen? So ma'am, sec square x will be here. So this is sec square x plus 2 tan square x. So 2 tan square. What about sec square? Now sec square can be written down as 1 plus tan square. So this is 1 plus tan square. Yes or no? It is not very difficult. Hindi, Telugu, Urdu and English. Kya baat hai? Very nice. dt upon 3t square plus 1. Now 1 by 3 you need to just take it common. So this is dt upon t square plus 1 by root 3 whole square. Do you remember this? 1 by 3. Then you have 1 upon a. 1 upon a will be root 3 tan inverse t into root 3 plus c. This is how you're going to get. Yes? Okay, next. See this? Yes, I'll give you notes. Don't worry. Right now, just understand it. Dx upon 2 sin x cos x plus sine square x. Okay, so what we are going to do is just divide by cos square x. Cos square x. And 1 upon cos square x is sec square x. And put tan x is equals to t. So sec square x dx will be what? dt. Cos cancel. So this is 2 tan. So 2t plus t square. Now I told you now, whenever you see 1 upon quadratic, 1 upon quadratic, what to do? 1 upon quadratic. So this is what? Perfect square. So just add 1 and subtract 1. So t plus 1 whole square minus 1. Yes or no? This is dt. Now this is that 1 upon x square minus 1 by 2a log of 1 by 2a. So 1 upon 2 into 1 log of mod of x minus a. So t plus 1 minus 1 upon x plus a plus c. 1 1 cancel. So 1 by 2 log of t. What is t? Tan x upon tan x plus 2 plus c. Okay. Yes. Okay. The next thing. Now, whenever you see sin x, just sin x, the degree should be 1, or just cos x or sin x cos x combination in the denominator, then what to do? Then you have to think about submultiple formula and you have to put tan x by 2 is equals to t. That's it. Sin x and cos x. See, do you remember this formula? Sin 2 theta is what? 2 tan theta upon 1 plus tan square theta. Cos 2 theta is 1 minus tan square upon 1 plus tan square. Okay. See, I'll show you by solving problems. So, whenever you see sin x and cos x degree 1 in the denominator, the very first thing will be tan x by 2 is equals to t. So, you want sec square x by 2 and 1 by 2 dx is equals to dt. Correct? So, first thing is just convert dx upon 1 plus sin x will be what? 2 tan x by 2 upon 1 plus tan square x by 2 plus cos x will be what? 1 minus tan square x by 2 whole upon 1 plus tan square x by 2. Okay, now 1 plus tan square x by 2, if you take LCM, it will become what? 1 plus tan square x by 2 will come here. And you know what? 1 plus tan square x by 2 is what? Tell me. 1 plus tan square theta is sec square theta. So, sec square x by 2. It will go up. It will be sec square x by 2. Okay. So, after taking LCM obviously. So, it will be what? 2 dt. So, 2 dt upon, what about this? You take LCM. So, 1 plus tan square x by 2. So, 1 plus t square plus 2t plus 1 minus t square. This is how it will be looking like. So, this is cancelling. 2. This is what? 2t plus 2. So, t plus 1 integral, and this is dt. 2 to cancel. Log of mod of t. So, tan x by 2 plus 1 plus c. Clear? Yes. And the last category of today, last category of trigonometric functions. Last category of trigonometric functions, okay, where numerator and denominator are combination of sine and cos. Remember, see, the previous category was all about the numerator by denominator. Previous category was talking about denominator. Now, numerator and denominator are similar, not same. Otherwise, it will get cancelled, no? But the format of numerator denominator is same. Can you see this is p cos x, q sin x plus r, a cos x, b cos x, b sin x plus c. Now, obviously, it is not compulsory that numerator is having cos and sine and constant. It can just have cos also. It can just have sine also. Okay, it can have both also. It can have all three also. Okay, based on PQRs format. This is the generic format. Now, if you get this, what to do? You have to write numerator is equals to a times denominator plus b times derivative of denominators plus c. Okay, see, I'll tell you by solving the problem, it will make more sense. First of all, this is 5 tan x upon tan x minus 2. I am going to convert this expression into sine and cos. So, 5 sin x upon cos x. Cos x will get cancelled out. This is what? Sin x by cos. If you take LCM, it will become like this. Now, can you see the numerator is sin x, denominator is sine and cos. So, it categorizes as p sin x plus q cos x plus r upon a sin x plus b cos x plus c. Now, what to do? Write 5 sin x, that is numerator will be a times denominator plus b times derivative of denominator plus c. Okay, so 5 sin x is equals to a times denominator is what? Sine minus 2 cos plus b times derivative of denominator is what? Cos plus 2 sine plus some constant c. This is constant c, this is cos. Okay, so 5 is equals to 5 sine is equals to a, compare the coefficients, a plus this is b plus 2b. And you know what? The coefficient of cos, if you compare in the right hand side, in the left hand side it is 0. This is minus 2a plus b. That's it. And the constant term is anyway 0. So c was anyway 0 only. Okay. So this is two things. These are the two things. Okay. Now, if I multiply this by 2 and subtract. So this is minus 4a and okay. Subtract. Multiply by 2. So 5 minus 0 is 5. A minus 4a is equals to 5a and this minus this will be 0. So a is equals to 1. The moment your a is 1, b is equals to 2. Okay, b is equals to 2. So in here, understand, now 5 sin x will be what? A times denominator plus a, what is a? A is 1. 1 times denominator. 1 times denominator plus b plus 2 times denominator derivative plus 0 upon sine minus 2 cos. Upon actually denominator. Sine minus 2 cos is what? Denominator. Now different. Now integrate. If you separate, you will realize denominator by denominator will be 1. So the derivative will be just x plus 2 times derivative of denominator upon denominator. Remember, if you put it as t, this will become dt. Integrate, so log of denominator, log of mod of sine minus 2 cos plus constant. So x plus, can you see x plus 1? A is equals to 1 and log of, so a is 1, option C is absolutely right. It's all about learning the formats and learning what to put when that format comes. Okay. All right. So let me explain you one more time. See, this was the result. Now 5 sin x is a times, this is your denominator. So a times denominator plus b times derivative of denominator plus c. Now if you compare, c is anyway 0 because there is no constant on the left hand side. Okay. And a and b you can get by forming the equations. So just solve, you will realize a is 1, b is 2. Now put 5 sin x is a is 1. So 1 denominator plus 2 derivative of denominator. So 1 times denominator. Now understand. See, 5 sin x is already there. Now this is sine minus 2 cos. Sine minus 2 cos. Sine minus 2 cos. Understand. This is the con. This is 1. 1 dx. Integration will be just x. Plus 2 is there. Now if you put it as t, this will become what? dt. Because this is derivative. If this is t, this is dt. Integration will be log. So log of mod of this t, sine minus 2 cos plus constant. Okay, so this is how your answer will be looking like. So just one thing I think I have forgotten about this 2. Right or wrong? You didn't even tell me also. So this is 2 times. So 2 is there. A is 2. So D is absolutely correct. Not C, but D is absolutely correct. Okay. All right. Right. So yes. Now integration of trigonometric functions. Integration of trigonometric functions. Now what is this type? Now this is a very good type, very important type. Whenever you see that there is a function of sine 2x in numerator, okay, and we have cos x plus minus sine x in the, see, f of sine 2x in denominator is cos x plus minus sine x in the numerator, then integration of numerator you will put as t, so that when you differentiate you will get the exact numerator. Okay, I'll show you with the help of an example. In fact, JEE Main PYQ 2021, it was asked in JEE Main 2021. So this was a PYQ. Okay, so cos theta minus sin theta, and you can see that there is a function of sin 2 theta in the denominator. So what we need to do is we need to integrate the numerator. So integration of cos is sin and integration of sin is minus cos. So now we are going to put sin theta plus cos theta is equals to t, so that cos theta minus sin theta d theta will become what? dt. Okay. Now one more thing, obviously, that the numerator part of this integration will become what? dt. But ma'am, what about denominator? Because denominator I want to write in terms of t. How will I write it? So for that, keep that in mind. You have to square it. If you square it, what will you get, ma'am? Sin square theta plus cos square theta plus 2 sin theta cos theta is equals to t square. Okay, so 1 plus sin 2 theta is t square. 1 plus, can you see? 1 plus sin 2 theta is equals to t square, which will give you sin 2 theta is equals to t square minus 1. Okay, so now 8 minus t square minus 1, correct? And dt upon square root of, can you see, this is 9 minus t square. Now 1 upon square root a square minus x square. Remember, sine inverse. So it is going to be what? Sine inverse t by, basically sine inverse x by a. So t by 3. And in sine there is no 1 by a. So this is your integration, right? Now what you have to do is just put. So this is sine inverse t by 3. What is t? Sine theta plus cos theta by 3 plus c. But ma'am, as per the question, they are talking about cos inverse. Then, so if it is cos inverse, you can convert the sine inverse is nothing but pi by 2 minus cos inverse sin theta plus cos theta by 3 plus c. So clearly, a over here will be minus 1 and b is 3. So minus 1 comma 3, option D is absolutely right. Yes, Ayan. Yes, Muskan. Okay, clear? Give me a big thumbs up if you've understood this pattern. Pattern understood kya? Pattern understood? Understood the pattern? Okay. Now we will talk about some special types of integration, or this is my favorite type, because you know what, this is very deeply rooted with the basics. In fact, in the first few lectures, do you remember the first 2 lectures of integration? Basically the first lecture or the second lecture where we used to do integration like by substitution. Okay, but then integration got a little ugly, right? Integration was all about learning formulas, learning the format. If you get this, do this. If you get this, do this. If you get this, do this. Like that. Okay. So now we are going to go in the first hour or second hour of learning integration era. Okay, where we just need to understand what to substitute t so that we can integrate. Integration by substitution, but not, it will be not straightforward. First, you have to do some manipulation and then only you can substitute. Okay, so this is, you can say, substitution but slightly advanced substitution. Okay, so this is fun. So whenever you see these type of integration where denominator has a lot of things, okay, so what you need to do is, in such case, especially this particular format where this is x power n plus 1, this is x, so you take x power n common. Okay, you take x power n common. The moment you take x power n common, what will happen? So this is dx, this is x, and you take x power n common. So this is 1 upon 1 plus x power n. Okay, so this is going to be your t. This you have to substitute as t. Okay, we'll do one question so that you understand it better. So this is the format, right? Dx upon this. Now you take x power 5 common. So it will be 1 plus x power minus 5. Correct or not? So eventually, and you know what? In this question, in such questions, always deal with negative powers. It's good to deal with negative powers. Okay. And it might look a little bit confusing also. See, this is x power minus 6 dx, and this is 1 plus x power minus 5. If you put, now understand, if you put x power minus 5 is equals to t. Okay. Now differentiate. So ma'am, minus 5 x power, what will you do? If you differentiate, you subtract 1. So minus 6 dx will be equals to dt. It is going to be what? Understand. It is going to be what? X power minus 6. So this is your minus 1 by 5. Minus 1 by 5. Okay. And this is gone. This will be dt. And this is your t. Oops. So minus 1 by 5 log of mod of t. What is t? 1 plus x power minus 5 plus c. Or you can also write it as minus 1 by 5 log of 1 plus x power 5 upon x power 5. After taking LCM, you will get this. Okie dokie? Yes? Clear? Shall I give you another question? Are you question ready now? Are you question ready now? So, minus 6. Achha, you're talking about this. Are you a next question ready now? Okay. So, this is your question. Can you see this question? I want all of you to solve it. Achha, tell me one thing that I feel from here I can see some extra light. Can you see? Can you all see? There is some extra light over here. Okay, if I switch it off, that extra light, is it better? I mean, it's better, but then I am looking dark, isn't it? Okay. Now, to fix this, I'll do one thing and you solve it. I'll do one thing. You're going to help me with studio lights also. Huh? Not better, right? It's right here. Okay, so are you solving it? Let's solve it. First of all, I can clearly see that sin x you have to put as t, so that cos x dx is equals to dt. So this is what? dt t power 8 plus t. This is dt t power 7 plus 1. Okay. So now you have to take t power 7 common. It will become t power minus 8 1 plus t power minus 7. I am going to go a little direct. I have taken t power 7 common. It will get combined with t, and eventually what will happen? It will become t power 8, which will go up. It will become t power minus 8. And this is how it will look like if you take t power 7 common. So this is over here is, now put this as a. So 1 plus t power minus 7 is equals to a, and minus 7 t power minus 8 dt will be equals to dA. Okay. So over here, this is dA upon minus 7. Okay. And this is just a. Okay. So answer will be what? Minus 1 by 7 ln mod of a. What is a? 1 plus 1 by t power 7. So this is mine plus c. Minus 1 by 7 log of mod of, this is what? Sine power 7 plus 1 upon sine power 6. Okay? Yes? Alright. What I'm going to do is, this is better, right? This is better, no? I was like, this is just slightly inconsistent. Here there is some light. Now I'll fix it. Clear? Okay. Now let's understand some other type of patterns also. So now whenever you see same pattern is there. There is some x power n, but here it will be x power n power 1 by n. If these kind of expression, wherever you see basically x power n plus 1 power something. In previous category, in just like category which we have studied just now, x power n plus 1 was existing, but now this time x power n plus 1 power 1 by n is there. So what you have to do is you have to put this as t power n. Okay, but yes, again take take x power n common. Let's do this question, this similar type of question. Can you see? See, now the moment you see the question, if you don't know the format now, you'll be like, ma'am, I don't know what is happening, I don't know where to start. Okay, so see, whenever you see so many things in denominator, you have to take maximum power common from the denominator, especially from the bracket. So what can I take common? X power 4, ma'am. So if I take x power 4, it will become x power 6. So it is x power minus 6 dx, correct? And it is going to be it is going to become 1 plus x power minus 4. Okay, power 3 by 4 is already there. Now you have to put 1 plus x power minus 4 is equals to t power something. What will be the power of t? 1. See, the power is 1 by 4. 3 if I ignore, the power is 1 by 4. Okay. 3 is actually the integral power. Now I am looking for nth power. So 1 by 4. So you have to put 4. Now differentiate. So it is going to be minus 4x power minus 5 dx, and this is what? 4t cube dt. Sorry, my bad. The moment I take x power 4 common, it will become what? X power 4 and 3 by 4. So 4, 4 cancel, x cube will come out so that it will become x power minus 5. Oops, my bad. X power minus 5. Now it's better. Okay. So now the question became very easy to you. This is minus 1 by 4 and it is going to be what? 4, 4 anyway cancel now. The minus sign is there. Just ignore 4 part. So negative of integral of this is your dt upon t. Okay. See, if this is 4, no, this 1 by 4. So t cube. Now integrate. T power minus 3 integration. T power minus 3 plus 1 upon minus 3 plus 1 and you have a negative sign plus c. Integration sign I am removing. So what will happen? This is t power minus 2. So that means 1 upon t square. This is what? Tell me. Ma'am, minus 2 plus 2. So 1 by 2 t square plus c. 1 by 2 t square. So t square will be what? Square root of 1 plus x power minus 4 plus c. Okay. Am I doing anything wrong? No. This is t cube. T cube integration is minus 3 plus t cube. Minus 3 plus 1. So minus 2. T square. So there is a square root over here. Sorry, actually let me check, Did I make some mistake? So it is t cube was, oops, I forgot something maybe. Yes, I forgot something now. This is what? T cube. Oops, t cube was already there. X power minus 5 is t cube dt. I forgot this t cube. Okay. Now t cube cancel. So it is minus integration of minus dt. So integration of minus dt is what? Minus t plus c. Now it's correct. So minus t square minus t means 1 plus x power minus 4 power 1 by 4 plus c. So this will give you what? Minus of x power 4 1 plus x power 4 whole power 1 by 4 plus c. Okay. So I think it is absolutely matching with option D. Yes, now correct. Now correct. Okay. See, the whole process is so there, but you know what? The first step should strike in your brain that if so many things are already in denominator, especially the higher powers, x power 4 is higher power. Take x power 4 common. Once you do that, now take common and push it. See, this is what kutur putur is, by the way. I call it kutur putur. What is kutur putur? You take x power 4 common from the denominator and push it in the numerator. This is kutur putur. That means manipulation. Okay. Here also, now this is one of my favorite question. NTA keeps on giving. This question is something, you know what, every 4 years that hidden question happens now. Every 2-3 years NTA gives this question. My favorite question. Okay. Why this is my favorite? Because there is some insight already given. Hint is already given in the question. If you have eyes, then only you will be able to see. Not like the just eyes. If you have actually brain eye. What is brain eye? Just you have to observe. Now x power 4, 8 by 7, x minus 3, 6 by 7. Okay. Now 8 by 7, 6 by 7. What is the relation between x by 7, 8 by 7 and 6 by 7? Tell me, what is the relation? Basically, the problematic part is this power only, no? This power is messing our brain. What if, understand, now suppose if at all this x, suppose rather than x minus 3, suppose in place of x minus 3, if it would have been x plus 4, 6 by 7, then what would have happened? If instead of x minus 3, same thing is here, then tell me ma'am, then 8 by 7 and 6 by 7 would have gotten combined? They would have gotten added. Okay, 8 by 7, 6 by 7, if you add, what will you get? Ma'am, 14 by 7, which is 2. Oh, that means 8 by 7 and 6 by 7, the powers are given in such a way that if you add, if you get a chance to add, then you can get a whole number. But ma'am, how can you add it? Okay, now you tell me, how are you going to add it? Okay, so you will be like, I am wondering, I wish that the question, in the question itself, rather than x minus 3, they would have given x plus 4 only. If instead of x minus 3, there was x plus 4 only, then what to do? Then ma'am, it would be easier. So what I am going to do is, I am going to create that. Whatever I want, I will create myself. So x plus 4 power 6 by 7 and x plus 4 power 6 by 7. Okay, I have multiplied and divided. In fact, you know what? Rather than writing x power 4 6 by 7 over here, why don't I do one thing? I just write x plus 4 power 6 by 7 over here. X plus 4 power 6 by 7 over here. Correct? This is also good. Okay, now what I'm going to do is, I am going to combine these two. That's what I wanted to do. So now this is going to be x plus 4, and the powers will be 8 by 7 plus 6 by 7. Tell me, ma'am, 2. So square. Okay, now understand, this is x plus 4 and x minus 3. So this is, see, here you can write actually x minus 3 upon x plus 4 power 6 by 7. And this is your dx. Yes or no? See this thing over here, let me write it over here only. This is what? X plus 4 power 6 by 7. So I have combined these two because they share same power. These two I have clubbed it together and these two are together. Okay. Now you understand what I did. I want to add these two, so I did that. Now what to do, ma'am? Still, what are you trying to do? So basically, my idea is, and I told you this also while teaching you quotient rule. Okay, one very interesting thing. You know what? Linear by linear, x minus 3 upon x plus 4. Okay, if you take this as t and you differentiate it, do you remember the quotient rule? In the denominator, you get the second function square. Derivative quotient rule. First by second. If you differentiate, ma'am, x plus 4 whole square. Can you see x plus 4 whole square you're getting? If you take this as t, so this automatically will get created. Okay, that's why, you know what? When I was doing something over here now, you must be noticing or not, that ma'am, you were writing x plus 4 here and then you were writing here. All I wanted to do is, I wanted to make sure that my x plus 4 should be in denominator because I want to take this as t. X plus 4 I wanted to keep in denominator. Why? Because I know when I apply quotient rule, there will be square of the denominator, second function. So my idea was, if I am getting x power 4 whole square I am only get when I put this as t. So x plus 4 should be denominator And you know what? X plus 4 is kept constant. In derivative of this is 1 minus x minus 3 kept constant. This is 1. Dx is equals to dt. X cancel, 4 plus 3. So this is 7 upon x plus 4 whole square. Dx is equals to dt. So can you see this is dt? This is dt by 7. So dt upon 7. And what about this? This is t power 6 by 7. Now integrate. This is going to be 1 by 7. T power minus 6 by 7 plus 1 upon minus 6 by 7 plus 1 minus 7, 1 minus 1 by 7. So it is 1 by 7. 1 by 7, 1 by 7 gone. And this is t power 1 by 7. So t power 1 by 7 is my answer. What is t, by the way? This is t. So this power 1 by 7 will be directly my answer, which is matching with option B. Have a look, let me know. Okay. Now this is also my favorite type, kutur putur only. Whenever you see so many powers, can you see? Crazy powers of x in numerator and denominator. What's the drill to do this question? Take the highest power from denominator common and push it in the numerator. That's the idea. So x power 7, ma'am, you can take common. So x power 7, if you take common, it will be x power 7 and then square is also there, x power 14. So if you take x power 7 common, this is x power minus 5 plus x power minus 7 plus 2. Square is also there. And this is 5x power 8 plus 7x power 6 dx. Okay, x power 14, push it in the numerator. So now 5x power. Be careful with the powers, otherwise calculation will be like very toxic for you. So minus 14 plus 8. So ma'am, minus 6 plus 7, then this is x power minus 8 and this is your dx whole upon x power minus 5 plus x power minus 7 plus 2 whole square. Okay, now put this thing as t. So x power minus 5 plus x power minus 7 plus 2 is equals to t, so that minus 5x power minus 6, this particular thing, minus 5x power minus 6 plus, sorry, minus x power minus 8 dx is equals to dt. Okay, so just this whole thing, if you take minus sign common over here, so this will become dt, minus dt, whole upon this is t square. So minus 1 by t square derivative will be what? 1 by t. 1 by t plus 1. So 1 upon t. What was t? So ma'am, x power minus 5 plus x power minus 7 plus 2 plus c. Now multiply x power 7 because I want my answer in the powers of x, positive powers, right? So x power 7 upon x square plus 1 plus 2 x power 7 plus c. Okay. So f of 0 is equals to 0. See, this is your f of x. Now what they are saying is f of 0 is 0. The moment you put f of 0, so f of 0 will become 0. 0 is equals to, this is also 0. So c is 0. Can you see? If you use f of 0, verbally you can make out, you can understand that, okay, c is 0. F of x is this. Now what about f of 1? So f of 1 is equals to 1 upon 1 plus 1 plus 2. So 1 by 4. Okay, option D is absolutely right. Okay, this was one of my favorite questions if I talk about integration. Now this question. I want you to think about this question and do it. Okay, I'll give you some time. To integrate. Done. Are you going to take x square common from numerator? Let's try to take x square common from numerator. It will become x. If it come out, it will become x. This is x power minus 2 minus 1. Whole upon this is what? X power 4. Am I doing correct? Is this what you have done? Okay, so this is x cube. Okay, and this is what? X power minus 2 minus 1 dx. Now x power minus 2 minus 1, if you take it as t square. Okay, so ma'am, minus 2 x power minus 3 dx will become 2t dt. Okay, so understand, this is what? Dx upon x cube. Dx upon 2 to cancel. Dx upon x cube is nothing but what? Minus. So minus t dt. And this over here will be just t. So answer would be minus t cube by 3 plus c. Now put minus t cube. So t cube. Okay. So minus square root of. Oops. So this is what? 1. Oops. X power minus 2 minus 1. And this is t cube, right? So what is t? Ma'am, square root. So this is 3 by 2 plus c. Okay, if you solve it now, if you take LCM negative of, this is going to be x square. This is 1 minus x square power 3 by 2, and this is also power 3 by 2. 2 to cancel, and okay, what you're going to get is minus 1 by x, and this is going to be 1 minus x square 3 by 2 plus c. If you compare now, clearly this is your a and this is your 3 by 2 is m. So minus 1 by x. Sorry, there is a cube, right? So this is your a. Minus 1 by x cube. And what is m? M is, ma'am, 3 by 2. So this is just 3 by 2. Or not? Ma'am, you missed a 3. I missed a 3. Oops. Okay. So there is a 3 also in the 1 by 3. Oops. 1 by 3. Okay. So 1 by 3. Minus 1 by 3. So this is 3. This is your 3. Okay. So now is it correct? This is your A. And what is your M? Actually, M is 3. M is 3. M is not 3 by 2 because root is already up there. No? It is just 3. So your answer will be what? 3 3s are 9. Minus 1 by 27 x power 9. Okay. So option A. Option A is absolutely matching. Good question. What do you think? Hai na? I mean, it is not that type of question which you see it and it is solvable. But it is something which is, I mean, if you see it, if you don't know it, you might go a little blank also. What to do? What to take common? What to put T? Okay, this is that type of question where you actually think that what to do. Shall I put some trigonometric substitution? So shall I take something and put something T? And nothing will work. Okay, unless you know that this is advanced substitution. Manipulation and then substitution. Manipulation and then substitution. Okay, yes, all right. Now the last thing which I want to tell you about integration is this. Mostly we have covered everything, almost everything. This is the last thing. Okay, so we are going to wind up in like less than 10 minutes. Okay, all right. Now suppose you see such kind of integral where x minus alpha and beta minus x minus alpha, beta minus x is involved. Put x is equals to alpha cos square theta plus beta sine square theta. Alpha cos square theta plus beta sine square theta. And you know what? You just differentiate, so you will get this. Okay. But now if both are having same sign, x minus alpha, x minus beta, then you have to put, this is actually slightly rare only. That's why I'm bringing it in the end. Okay. So yes, this is x is equals to alpha sec square theta minus beta tan square theta. Okay. So this is how it is. And yes, that's what you have to put. And if at all you will see both same signs but both in denominator, put x minus alpha is equals to t square. One of them you have to put a t square, either x minus alpha or x minus beta. So yes, now this is very rare. NTA doesn't ask questions from this. Okay, so this is how it is: x minus 2, 3 minus x. So let me just show you how to do it. So whenever you see x minus alpha, beta minus x, put x is equals to alpha cos square plus beta sine square. So 2 cos square plus 3 sine square. If you differentiate, what will you get? Tell me. So ma'am, dx is equals to 4 cos theta sine theta negative plus 3 to the 6 sine theta, then cos theta. Correct? Now sine theta cos theta will be what? So it is going to be 2 sine theta cos theta. So 2 sine theta cos theta is sine 2 theta only. Okay. And also just convert this into completely into sine. So this is 1 minus sine square. So x will be what? You will get x is equals to 2 plus sine square. Okay. So over here now put, see, x minus 2, understand, x minus 2 is sine square theta. So this will become actually sine square theta and this will become cos square theta and this is sine 2 theta d theta. So this is tan theta sine 2 theta d theta. If you solve it, you will get this. Now integration of this is not a very big deal. Integration of this is not very big deal. Apply gold, 1 minus cos 2 theta, integrate and eventually convert. Okay, so again, these type of questions are all about if you know, if you know it, then only you will be able to do it. Okay. Now, I think 99% integration we have done. Okay.